So, um, so hi guys. Once again, I welcome you all to today's episode of our Python series, right? So in our previous episodes, we've covered a lot. As you would all agree, we kickstarted from the very basic. We've ventured into understanding Python itself as a name, understanding its history, understanding how the name was coined, also checking all of its use cases amongst other things we've checked. So we've also delved deeply into functions, variables, control flows, if statements, and the likes, right? So now, why am I revisiting all this? So it's quite essential to mention them because these are all building blocks to what we would be delving into today. So today's session is on Python object-oriented programming. To many, it appears to be a buzzword. To some, it's just a fancy name. And I want to assure us all on this session today that by the end of this session, we would all also belong to that sect that would be saying going forward, objects-oriented programming as just a fancy name because it's really nothing particularly. So it's just like a building block on the foundation you have built in the past on the Python basics. So if you've known and if you are very familiar and confident with the likes of function, control flows, the loops, variables, data types, amongst others. So you shouldn't have any issues per se regarding tackling any issue or challenging or challenges on OOP in Python. Having said that, I'll be sharing our contents of today's session so that we can walk through that before deep diving into our playhouse. All right, today we'll be checking objects-oriented programming in context. To me, I believe if you don't understand the rationale or the logic of a concept, right, it will be difficult to work with it or to approach its problem solving. So it all boils down to understanding its conceptual framework. What it sits in concept. What do you understand in it? So before trying to attempt any coding on it. So after this makes sense, so then we'll be going into also check fields. You would also be checking, I would understand, I would explain what field is. We would also be knowing the types of fields that we have in OOP, Python particularly. You would also be checking self, right? So that self, almighty self. So I believe and I agree with larger percentage of learners of OOP that one of the concepts that would throw you off balance while learning OOP itself. So you are going to demystify that in this session today. So there would also be extending into classes, you check methods, you would also understand and appreciate the innate method, popularly known as the magic method. So after that, as I've said before, we'll check the types of fields that we have. So then we'll be summing all this up with OOP pillars. However, so this is the approach I'll be using in this session, right? So to many, they see or they understand Python differently from its pillars. So I coin or term its pillar the encapsulation, the abstraction and inheritance. So to many or to some, they see it differently. So I'm going to ensure I walk us through how we can just see this pillar as just features or simply put, characteristics of object-oriented programming. So it is nothing specific or typical different from you like working on OOP in general. So all this would make sense in a second. So without further ado, so let us understand what we mean by OOP. So when we say OOP, so it's just a way of organizing a program, right? So that would allow us to combine our data and functionalities. So and wrap everything together in a class, right? So how do we mean? So it's just like having a building or a foundation that allows us to like have both templates, right, of what you will be using to create further architectural design, and also what are the capabilities that that template could also do, right? So that we can have everything together in one place. So that is basically what object-oriented programming is. And this would make sense in a moment. So OOP, 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 it's like a fuse, right? So basically, you should just bear in mind that the two major concepts in OOP are class and what objects. So what objects are, we are going to understand that also in a moment. What are objects? What are variables? What are fields? So what are attributes? All of this would make sense in a moment, right? So now let me cite an example very quickly so that we can visualize what I mean by this concept. So when we say OOP, unlike the procedural programming approach, right? So like the procedural oriented programming. So what we've been doing so far is procedural. So like by approaching our program with just like defining functions separately, defining variables separately, and trying to import one in other module to make them connect, right? And other related or similar approaches to programming, right? And it is important to stress that it is not really compulsory that you must write your program using OOP. You can also use procedural, so which you are familiar with. However, so it is just like an industry or a standard recommendation to write a very comprehensive and neat program using OOP. So we would also appreciate that in a moment. So now we now say OOP. What does OOP mean, right? So OOP is just like giving us the capability to design a project that would allow us to simulate a real life object. So when we say object, right, we say object oriented programming. So what does this mean? So it is just simply, or to simply put, it means that we want to like have something that is similar to um, objects characteristics. So for instance, now let's cite a car as an object. So if we say a car is an object, we have two expectations for car, right? One of the expectations we have for car is car should have attributes, right? So one of the attributes of a car is a car could be of varying colors. It could be yellow, it could be red, it could be green. That is an attribute or a feature of a car, right? Another feature of a car is it could be a portable car, it could be a Jeep sort of. It could be a big car. It could be a medium-sized car and the likes, right? So another feature we can think of a car is car could also it could also it could be like it could be of different models, right? So those are features that are basic or primary to car. However, in addition to cars features, we can also think of cars capabilities, right? How do I mean? So capability of cars are what can a car do? What what are the properties of a car? What are the capabilities of car? So one of them is car can move, right? Car can what? Um, can go fast. So car can also, in the course of moving, can stop, card can go forward, it can also what come backward. So these basically are two what major approaches that we can think of a car. We think of its feature and think of its capabilities. So another example I will cite, thinking of objects is, let's say, a dog, for instance. So one of the attributes of a dog is a dog could be of different colors. We have like orange, is it orange? I think orange somewhat colors of dog. We have white dogs, we have black dogs, right? So now those are the features. Now, what are now the capabilities of a dog? A dog could run, a dog could bark, a dog could eat, a dog could also do what? Bite, amongst other capabilities of a dog. Now, how does this now connect with programming? Now, so this approach is now employed in object-oriented programming. That is, we want to build a software that would give us, that would be in the same class, right? Everything would be in the same unit. Everything would be in the same room. So what are the things that will be in the same room? One of them is the feature of that object you are building for. And what can that object you are building for do? I don't know if that makes sense. So I'm trying to relate this to object-oriented programming. So now when we say object-oriented programming, we are just like employing the same understanding we have for all these objects I've cited and what replicating it in programming. Okay, you want to write a program, right, that would give us the ability to have both attributes and both capabilities, everything in the same building. That is basically what object-oriented programming is, right? So now, if we now have an understanding of object-oriented programming, so if we appreciate this, right? So we now have like arrays of terminologies in object-oriented programming. So amongst the most common word you'll be hearing is objects, you'll be hearing instance, you'll be hearing methods. What is an instance or object? What is a method? Right? So all these are what you are familiar with already, right? They are just typical, right, to object-oriented programming. So now let's say we say in our normal other way of writing program or of building software, so you can just say x is equal to um, x is equal to 10, right? X is equal to 10, right? So here, what are we going to call X? We are going to say X is a what? Is a variable. Am I correct? Right? X is a variable. You would all agree with me. So now, if this same X you have defined here, if it's now find its way inside a class, because we use a class to construct OOP, if this X find its way and meet itself in a class, it becomes field. It becomes what? Field. So it is just terminology. It's why I say all these things are just buzzwords. They are what you like, you are very familiar with. Now it is just like a change of name. Okay, I want to change my name from Ibrahim to Olawoyin, right? I am still the same person, but with a different name. So it's still the same thing. So when it is inside class, it becomes a field, right? Or to some contexts, to some or to other related programming languages like Java, C, and the likes. So they recognize this in a class as attributes. But in Python, it is known popularly as field. However, it is still used interchangeably. So some, even in Python, some still refer to it as attributes, while some still want to go with that convention, with the naming convention of what field. So that is one breakdown I would like to do. So now, having understand what a variable is, right? So I've said in when it's find its place, or find solace in class or in OOP, it becomes field or attribute, right? So that is that basically. So now the other word that's most times or many a time also create confusion is methods. So method is also something we are very familiar with. So for I even to this extent, I believe virtually everyone in this session has worked with method one time or the other. So that's I believe, right? So, but what is a method, right? When it is in um, Python or in OOP, right? So it becomes a method. But what we've been working with basically is just what function. So what is function? So function is what we are very familiar. We just say what def, a basic function, right? Add. So you can just say pass. So this is what we are very familiar with. So is anyone here who hasn't written these lines of code before? None, right? So, but it is outside OOP, it is function. Inside OOP, it is method. I hope that is clear, guys. Please, let's react if it is clear before I proceed. So let's please react.
Yes.
Awesome,
Yeah.
awesome, awesome, awesome. So outside OOP, it is function. Inside OOP, it is method. So that is it basically, no more, no less. So I would like to, that I am trying to paint this emphatically so that we can build a strong foundation before we start to deep dive into constructing our project for today, right? So now, the next thing I would also want to explain or elucidate in in-depth is objects, right? So objects and also instances. So object and instance, right? They are synonymous, right? They are just used interchangeably. So in the course of this session, you might hear me use them interchangeably. So sometimes I would say instance, sometimes I would say object. I mean the same thing, right? So, but what are what objects? So now let's now have a very simple OOP program, right? So that we can understand what object is. So I'm going to um, clear this out, right? So let's say now to begin with OOP, so there is a convention for it, right? So and the convention is there's a keyword. There is a first keyword that must be used. So it is this that interpreter would read and understand that I am to interpret this program as what's objects oriented. So and that keyword is what? Class. By the time interpreter or Python sees this class, it understands that, okay, everything following suit is what object, is what OOP. Everything in Python is objects, right? So as it is fondly said, right? So now we want to write a simple class so that I can use this to explain what object or instances. So let's just say we have a class of person, right? So after defining class using the keyword class, it is followed by person. So person is what? The name of your class. Person is what? The name of your class. It could be anything, right? So then followed by a parenthesis and a what? Colon, right? So since this is just a basic class, so you can just say pass so that you don't have issues with what? Interpreter. So basically, we have defined the class, right? Even if it doesn't, even if it is, even if it is not complex already, but we have defined a class, right? So now, what are now objects or instances? You know, I said earlier that the essence of all this is to allow us to create objects that is similar to real world objects that would be able to have features and also be able to perform sophisticated um, attributes, right? So now, this is where this object now comes to play its duty or role, right? Now, object is just like what? Creating like an instance of a class. Let's say, for example, now, this person now, I want to have a program of persons, right? So these persons, and another thing equally necessary to emphasize in OOP or why defining your class is that class is just a template, right? It's like a template that you want to use to create multiple objects. So it allows us to approach code reusability so that when you are unlike procedural approach, whereby many things you would need to recode, redefine, or repeat yourself over and over and over. But with OOP, once you create a class template, then you can start creating objects from that class template. And now this is where objects comes in what play. So yeah, let's say we want to create object of this person now, right? So we can just say objects. So let's say object example, right? So now this is the convention, right? This is syntax for creating objects. So you can say object example, then is equal to, then you now call that class name you defined earlier. In this case, we say what? Person, right? Then you close, you add open and close parentheses. So now, this is now referred to as the obj underscore exp would now be referred to as what? An object of the class person. Does that make sense? Obj now is now what? Objects of the class person, right? So we are going to have like a demonstration that this would that would make it more relatable, right, in a moment. But I just want you to understand here that what we just did now is we've created an object of the class person. So since we are not doing anything complex here or complicated, so let's just say we want to print this. So here we can say print oh, so let's say we want to print this and see what happens. So can you see it here? So on this displayed terminal, right, where I have the outputs of our class, it states that this main, like this dot person, objects at blah 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 blah. What this is stating is it's trying to enunciate that you have created an object for this person class that is being stored in this is the storage location that is stored that object I just created, right? So because this is not performing anything, this is why it is very basic. So now I have said before that you can now create multiple objects from the same word class, right? So let's now say we want to have another object again. So we also want this object to also use the same function of our class and the same features. So you can just say we have object 2. So object 2 also, we are going to also give object 2. We would also assign the class to object 2, right? What's this? So I'm trying to bring up my keyboard. Okay. So here also would say what? Person, right? So now let's now print this one also. Let's print object 2 and see what happens. So we say obj exp 2. So let's see what happens now. So as you can see, can you see? So if you notice, you would see that the values of their storage location differs. So this is because there are two different objects we have created from the person class. So if you are hearing object, object, object. So this is just basically an illustration of objects in OOP. So we are going to have a deep dive practice so that we can now check how these objects can access our methods and our attributes inside a class. Then it would now begin to make sense. But now I want us all to understand what objects are and how to instantiate or initialize an object. And this is basically the syntax for it. So if there is any question, please let me know before we proceed. Okay, so I believe we are all fine with this. Then we can now go ahead and define our objects for today's session, which would allow us to build a software. So as we all are, okay, Victor has a question. Yeah, Victor, you can unmute, please.
Okay. Can you hear me?
Yeah, I can hear you.
Okay. So my question is, if we want to print something like this now, because during the week I observed something like this. So I want to ask, is it not possible for we just to print like person? Like instead of storing person inside another variable, can we not just write print person instead
Can
of
we not
storing
just print? Can we
person?
not just print person?
Yes, instead of storing it inside another variable.
I don't think I understand your question. So, do you mean can we say something like this? Print
Print into bracket
person?
person.
Is that what you mean?
Yeah, something like yeah.
Oh,
I don't know if
sorry.
the question is ideal, but I
Yeah,
just
basically you can print person, but however, so if you have like functionalities or methods already defined for person that you are trying to track. We are going to see that in a moment. So when we venture into this session deeply, so person per se can also, so under person, this is where we are going to learn class attributes and class methods. We are going to learn class attributes and class methods. So how we can use a class also to traverse, right, in our class program. So how we can also define or design programs that allows us to use a variable that belongs to a class. Because I said before, we have types of variables. So we have class variable, and we also have we also have attribute variables, right? So we have instance or object variables, and we also have what class variables. So by the time we define a comprehensive class now that makes sense, right? So we would see how to navigate all of this. So definitely to answer your question, you can actually print person, right? But what are you printing person on? So you have not defined that in your class now. So if you just print person now, so let's see what we have. So can you see? It's also printing the memory where person is stored. So everything that is being printed on the screen are just where they are stored, because we have not defined anything basically. We have not said do this, do that, right? We are just like storing them in the memory. That is why we are seeing this on the screen. So I hope I've been able to answer your question, Victor. So I also have two questions here. Python to hold on or skip this part. Okay, thank you, Wisdom. Thank you, Wisdom. Thank you so much, Wisdom. So that pass basically is so that because I wanted to cite this as an example, right? So because I need us to appreciate how to instantiate an object before going far into defining a complicated or complex class, then invoking methods and attributes inside that class. So now, if I don't put this pass here, we don't have anything. If I remove it, see what happens. Can you see? We have an error. Object, blah, 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 unexpected and indexed block after class definition on line 2, right? So yeah, we have not defined class to do anything. We just left it fallow, right? So we can't like perform anything on it. So now for Python to allow us to go, you can just, this is just like how do I put it? Just like saying figurehead, like a figure. You just stay there just to allow me to what, I'm coming back. Okay, yeah, yeah, fine. By syntax, it will not allow you to just leave it here without any like indented block of code under it. An if statement that you are familiar with. While declaring an if statement, you can't just say if blah 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 is this, defining your statement and now skipping to another line of code, ignoring that your if statement. It would what, affect or crashes other subsequent code. Now for it to allow, maybe you want to come back to now give it like a full definition or what you want, you can just say, okay, pass for this time being, then I will come back. So this is what we just did basically. So I hope that is clear, Ogusaken. So I also have another question. If there are questions, please, this is the right time, this is the best time to ask, please, before we start to go deep. So I hope we are all clear on all these basics and the concepts. So if you are good with the concept, then we can start with our words, with the projects we want to build for today. So now, today we'll be building um, a real-time, a real-world functional bank application, right? So this bank application, we would define it in the sense that it will be able to have some features. Now, it should start clicking now. It should start with clicking now. I said what? This bank app should be able to have some features, right? And also should be able to perform some functionalities. Now, if you remember, I said it before, we are just like trying to simulate the same thing of our real life objects, which I cited cars. But this program we want to build now, I want it to be able to what, perform some features. So features like what, should be able to have users that should be able to what, register. Users should be able to have names. So users will be able to use first name, last name. Users be able to have email address. Users should be able to sign up. Users should be able to sign in. So when these users now have these attributes, we can now affiliate attributes to specific objects. This program I'm building, I am building it for like the larger audience, end users. Me, I'm just building a template. Anyone can use it. It is those individuals that are using it that are now the objects. So that is what it means essentially. The end user reacting or using your software are the objects. They are interacting with it, right? So now being able to differentiate user A from user B. Ogushakin would use this app. Ogushakin's information or data should be stored differently and shouldn't conflict Victor's data in the database, right? So these are what the commonalities of object-oriented programming. Now, having have features, also this app should also expectedly in a bank application, I should be able to what, to check my balance, right? I should also be able what, to deposit. I should also be able to withdraw amongst other capabilities of bank application. So this is the same as what the functionalities or the abilities that your object should be able to perform while they are relating with your application. To this extent, I want to believe object oriented program should be clicking now. It should be clicking now at this moment. At this point, it should be clicking. We want to build a software, a program that would enable us to have individual attributes for users, unique attributes for users, right? However, this user should also be able to perform extensive functions while relating with my application, right? So that is what we'll be building. So now, without further ado, so we are going to kickstart now. So as I have said before, to begin with, the first thing we need is to what? Use this keyword class. Then after class, we use our class name. So now, let me think of a class name. So we are building. So let's say I have like a bank, right? I am running a banking business. So the name of my business name is, let's say, First Choice. So if my business name is First Choice, so I think it suffices to just use that as my what program name. So in this case, I'll just say First Choice, right? So also it's also a convention in while defining your class name to start the initials with capital letter. So as you can see here, my F is in uppercase and my C also is in what? Uppercase, right? So now the next thing is what? Use your parentheses, then your colon. Sorry, the colon should come after the closing parentheses. So now I have defined my class, right? So now what are now the things my class wants to do? You know, I mentioned while I was introducing our topics for this session that I am also going to emphasize and stress the innate method. Now we are going dive now. We are diving deep now, rather. So innate method, the magical innate method. So what does innate do? It is innate that gives us the capability to define or to construct what we want our object attribute to be. Don't forget, I have said what attribute is. Attributes are the same, attributes of field, right? They are the same as variables, right? So attributes and field are the same as variable. But while you are doing OOP, you use attribute or use field, right? So now we want to now define the features or the capabilities that we want this our bank app to be able to perform while our users while our objects are relating to it. Now that is when you now what the first thing you need to do for this is to use what the init method. So how is init method defined? Init, it's just like an acronym for initialization. This is the method that is called whenever you want to instantiate an object. Instantiation simply means creating a new object, as we did earlier in our person class example. If you still recall, so let me take you back a bit. We defined a person class and we initiated it with obj underscore exp, right? Had it been we had had it been we had a program under our persons class. By that time, I called the obj underscore exp, right, object. It is that init method that would answer. I hope that is clear. When every time you are what creating an instance of a class or an object of a class, object instance are the same thing. I don't want us to get it confused, right? So I'll be using them interchangeably. So and objects and so while creating it, right? So what will be called at that instance of creation is your init. So since since this our program is going to have features, then let's define our init. So it is very simple. So this is just the syntax, right? So just a syntax. So just say def underscore underscore init underscore underscore. So that's it. Def space underscore underscore init then underscore underscore. Then we what add a what a parenthesis. I said it. What we are doing now, we are defining a method, an I related method to our regular function. So as I also cited earlier, you wouldn't define mention you wouldn't define function without including def keyword, as we are all familiar with. It's the same thing we are replicating here, right? Just that if you want to define feature, right, there are some convention you must follow, which is what why defining a method, an init method that will instantiate your object, you must use init. So it is just init, right? So we have defined this now. So now this init now takes one compulsory parameter, right? It takes one compulsory parameter, which is self. Self, self, self. This self also creates a lot of confusion for learners of OOP. right? So self would make sense in a moment. Just bear in mind, I am going to explain self extensively and ensure everyone on this session understand it. Like, but just bear in mind that while declaring your innate, the first compulsory parameter is what? Self, right? So after defining or including self, this is where you now also add other custom attributes you want your object to have. So in this case, we want our object to be able to what? To have first name, right? So we want them to be able to add first name. So in this case, I will say first. We also want them to be able to have last name. So I will say last, right? So we also want them to be able to have, okay, to also be able to check balance. So as you can see here, can you see? So these are the what basic features I want my object to be able to have. Aside from the compulsory self, I want them to be able to use their first name, right? To be able to use their last name and to be able to check their balance. However, because basically it's important for Victor to be able to tell apart is what record from Grace, right? So, and how do we do this? It is when it is until Grace registered with her first name and last name and saved it in our own object database. So everything she's doing afterward would now what be referring to the object that is unique to her to what interact with other functionalities in our program. So we are going to see all of those in play in a moment, right? So now, basically, we have defined our what? Our method. So now I want to ask, is there any difference with what we just did now to what we've been doing before while defining function? It's simply the same. So as we all know, to define a function also, what we just do is just do our def, we give our function a name, inside the parentheses, we define our parameters depending on the kind of parameter we want, either keyword, either default, or either positional. So which are all the same here also. We can also do everything here also. We can use default, positional, or keyword, right? So I will leave it simply like this. So now after defining this, so the next thing is now to what? To say that self dot first. I'm going to explain what this means, right? And this is where I will go in depth on self. So, but let's follow through this syntax first. So we are going to say self dot first is equal to first, right? Then, as you would have guessed, you would also say self dot last is equal to what? Last. Then, and lastly, we would also say self dot. So I want to introduce something very quickly here. So now, what I'm doing now is, I said we have instance variables and we have class variables. So instance variables are variables that are unique to objects. In this case, you would all believe that we all have our unique first name, last name, right? So, and we would all have our unique balance in our words that is unique to us, right? So these are what? These are instance variables, anything that is unique to an object instance. However, if there is like a feature, like a shared feature amongst variables, amongst objects, so that is known as what? Class variables. So which I am going to introduce in a moment. So class variable in this sense, we can think of, let's say for example now, so since we are building a finance application, right? We can say something that could be common to all objects of this program is, what can we think of? We can say, okay, maybe if you want to check their interests, right? So if you want to check interest now, maybe I want to, at the end of a specific um, time or period, I want to give all of my objects 10%. So because I am giving every object 10%, in this case, it makes sense to use a class variable because I'm applying it to all objects existing in my class. So in this case, you can use what? A class variable. On the other hand, if it is specific to a what? To an object, you use what? An instance variable. So an instance variable are what you define under your init method as we are doing now. Now, for instance variable, where I went was, for instance variable, we now have what we know as what? The public variable and the private variable. For public variable, an example is I just defined self dot first is equal to first, self dot last is equal to last. Right? That is public. It can be accessed. Like I am not like doing any access control on it. It is open. It's just like a library. Right? In a library, we can have a public library and we can also have a what? A private library. In public library, you can just go you have an open shelf. You go, you pick anything you want. But in a private library, so you have to before you can take anything from that library, you have to meet with what staffs working in that library. So it is them that would know where those are kept. So they will now go and get them for you. So it is the same here. So here we have some variables that we don't want access to be, you don't want them to be accessible outside our code boundary. So, and these are always variables that are sensical. So this is where you see some maybe you are saying secure, you are building a scalable and secured program. So anything relating to balance, you don't want end users to toil with it. People are very manipulative and corny, right? So in this case, we are now going to define our balance variable as a private variable. Right? So how do we now define a private variable? It's going to make sense in a moment, right? So I'm still going to explain it further. So to now define a private variable, so instead of just saying self.balance, we say self.__balance is equal to balance. What this does, we would see it in practice in a moment. So I'm going to demonstrate that for us while we are testing out the variables we are creating at the moment. So another thing I want my object to be able to do is also email, right? Because while they are registering with us, so I want to be able to create an email address for them. So since we'll be using email, we will be what? Coining email from their first and last name. So this is why we don't need to still be declaring email here. So because there's one popular practice for in Python that do not repeat yourself. So it's expected to be always. No, it's double underscore Clement. It's double underscore to declare a private attribute. So the syntax is double underscore, not single. So
Okay.
if it was single, it would have been flagged here. So let me add single so that I can see. It's not flagged, but it's double. So by the time we run it, so if it is single, we are going to know. So now we want to create email. So we say here self.email, right, is equal to what? So now I'm going to reintroduce for those of us that missed our slicing and indexing. So I'm going to introduce that very quickly. The string what? Slicing and indexing. So here, now this is what we want to do. So all these things we've been learning so far, you would now be appreciating them now, right? So in slicing, right, in one of our previous episodes, so I explained this like in details, right? So, but now, this is what I want to do. I want to now, from the first name and the last name of an object, I want to get an email address from there. But this is what I want. I want the email address to be their first name dot the first two letter of their last name. Again, I want the email address to be their first name and then the first two letter of their last name. So what do I do? It's very easy. So since we already have our first and last declared, so I'll just say first So here you say what? Self. We will say first, right? So now remember our slicing, right? Remember our slicing. You know, in that session, I said what? To use slicing, if you want to get all the string, so you just leave it as empty. The first parameter should be what? Empty, while the last parameter should also be what? Empty. So what you are saying basically is, okay, fine. No, if the first name is Clement, so get all the characters in Clement, all the elements of Clement from C to L, from C to T. I want all the characters in it. So that's what I just did here. So we now want to get the first name. Then this is where we now do concatenation. So if you also remember string concatenation, it's just simply like trying to conjoin string words together to make a word, to make, I'm trying to add up different words, multiple words to make a word. That is string concatenation. And it is very simple. So you just use add, just like doing addition of string. So, right. So now I have said what I want is first dot, right? So in this case, I will now say dot. And again, I will say what again? Plus. So next should be what? The first two letter of the last name, right? So I'll now say last, right? Then I'll introduce my slicing again. So in this case now, so what am I going to do? So we said we count from index 0, right? So, and if we want to fetch the first two letters, so what would our end index be? So since, let's say, for instance, let's say our first object is Clement. So in this case, we just want it to be um, Clement. If Clement is his first name, then ODEH. From that ODEH, we need just OD. We don't need the ED, the EH rather. Right? So in this case, we just say what? So since we are starting from the first character, you leave that empty. So and for this one, you know, I mentioned, I stated it earlier in our previous version of slicing that you canvas all through, but not including the index containing where you want to stop. So in this case, so what are we going to add here? So if we say, oh, we want to take the first two and it starts from 0, what are we going to add here to stop?
1.
You say 2. If we say 1, 1 will stop at O.
Then 1.
Yeah, yeah, 1 will stop at O. But 2, E is 2. E is 2. But as I have said before, if you include the end, it would not what? It would exclude it. To count from the beginning and exclude the indicated end. Do you get the idea? So now the next one is now so now let's say we fetched the last name, then we'll say plus again, then our domain name. So let's say our domain name is, since our company name is first choice, you can just say at firstchoice.com, right? So basically what we are saying is oh sorry, this is a string, so it should be in quotes, right? So basically what we are saying is every object we are creating, so by the time they want to create their email, coin it from their first name dot the first two letters or the first two alphabets of their last name, then add it to at our domain.com. So that is what we just did basically. And with this, I am happy to let you know that we have what? Instantiated, defined the init method. We have what? Defined the init method. Now let's now check how this works. Let's now react or interact with what we just built, right? So now let's say we want to create our first object. We want to instantiate our first object. So now let's call this our object a what? Let's say is a what? A customer. So in this case, I will say CUST. Now let's pay close attention here, please. So this is what we call instantiation. And I said before, when you instantiate, this is where you are trying to build unique attributes for your users, right? Now, and what happens in the back end is it is this init method that will be called. By the time I run this, then it will supply all this information. And this is where I'm going to explain this self. Let's place close attention, please. So now we now say, you can give this thing any name. This is your object. This is our object that we want to create now. So now you now say CUST is equal to, you now put your what? Your class name, as I've explained earlier, right? Your class name. Then in our init method, we defined 4 variables. And while I was explaining functions to us earlier and parameters in our previous episode, I said that all variables must be what assigned, are all parameters rather. These are parameters. All parameters must be assigned arguments, right? Except you have, like, let's say you have default parameter, which you have defined while declaring the function. Now, in this case, if I had said that before, now if I now want to assign argument to this, if I now say Clement, right? If I say Clement, then I'll say ODEH, right? Then I'll say his balance. Clement is a big man. Should have, like, let's say he has $50,000 in his accounts, right? So Clement has $50,000 as a balance, right? As his balance, right? So, and he has his first and last name. But while we are defining our init method, right, we defined or declared 4 parameters. Why are we now assigning 3 now? So this is where we need to understand self. This is where we need to understand self. You now see this self that we put here, right? It would now be seen as, this is how Python would see it. Let me do something so that we can understand. So now I want to print the first name. For now, our user have started to interact with our program now. So, but I want to print now, maybe Clement just want to check if his first name is correct. So he now clicked check first name, right? So when he clicked check first name, it's the same thing as this. How did I call first? Because I said this object, this CUST, right? Is this CUST, which I have defined as the object that I will be using to access the attributes inside these methods. We have done this before. We have used this knowingly or unknowingly in our previous session and in our respective projects and practices. If you have worked with lists, if you have worked with dictionary, if you have worked with mass module and the likes, you would have done something like something dot something. So that's the same thing we are doing here. So we want to access Clement's first name. Maybe we don't know his first name. We want to check his first name, right? So this is where we now say what? CUST dot first. Now, this CUST is this self that we define here. It is this CUST that will now come and replace this self. That will now check that self dash first. We said what self dot first is what? First. Does it make sense? This what CUST. Self is just a placeholder for the object we are going to define or declare. Now that we have declared an object, we assigned it its value, right? We have the first name, we have the last name, and we have the balance as defined. Now, I want to check my first name, right? So I will now say CUST dot what I want to check, which is first in this case, right? Now, how Python will now interpret it is, Python will now come again. This CUST will now be replaced by this self we defined while declaring our init method. Then, to now also be replaced by this self dot first here, to now turn to CUST dot first. Then anything we have at first will now be output for us to see. In this case, it is what? Clement. Now let's see and confirm if this is so or not. Let's now say we want to print cust dot first. Now let's see what happens. So let me check. So what do we have output? What output do we have on the screen? We have what? Clement. We have started interacting with our what? With our software. Clement is a new user. He registered on our application. He's signing up. What we are doing is sign up. He has entered his first name. He has entered his last name, and he has entered his first name, and he has a balance with us. Right now, Clement wants to check his first name. Now click on check first name, or just click on display first name. So this is the same thing we did here. Then it's displayed his first name on the screen for him. But in the back end, this is what Python is doing. Is this what we just did now is the same thing as now saying that, now look at it. Same thing as saying um first choice. Can we see? First choice, then let's now pass, let's say first choice, then first dot, no. This would not make sense. Now let's define more. I want to introduce something, but this is not the right time to introduce that. This is not the right time to introduce that. So I'm going to introduce that when we have more methods, right? It's going to make sense then. It would create confusion if I should introduce it now. So I'm going to introduce it afterward, right? So, but basically, this CUST here will be replaced by this self. Then it will now come here and turn to self to CUST dot first. Then anything we have as the first name will also be replaced by what, as we all know what parameter does, right? What variable does. It's just like what keeping, as I've said before, attributes in OOP is the same thing as what variables that we are familiar with. So this first is saving Clement. This last is saving Ode. Balance is saving 50,000. It's the same thing as what variable we are familiar with. But if it is inside OOP, it is known as what attributes or field. Right? So now that is one. Another thing we also want to check is, okay, Clement wants to check his email after registering. He wants to know what his email address is. Can anyone tell me how we can access email address here using the same scope we used to fetch our first name? So how can we check our email address here? So Clement wants to check the email address that has been created for him when he signed up, so that I would know what he uses to sign in subsequently. So how can we access email address here from this program using the same scope we used to access first name? Can anyone try?
That means we'll print self.email.
Don't forget I said that this self is just a placeholder for anything we define as objects here.
Yeah.
So can you recap? Can you recap, Abashakin?
Yeah, I understand. So we are
So what
going
are we
to
going to have now?
we are going to print
CUST
dot email.
dot, thank you. CUST dot email. As simple as that. CUST dot what email. Now let me run and see what we have here. And let's see if all this concatenation we did here works or not. So what do we have here? Can anyone read it out? Can anyone read it out, please? The email address we have here.
Clement.od@firstchoice.com.
Thank you. Can you see that? So we use slicing to achieve this, right? So now our user, this now, I would now revisit what I was explaining on objects before. So now what we just did is we've created it. I said it before, it's either you call it instance or you call it objects. So now we have created objects. An object of what? CUST of the first choice class. I also said before that when you are defining class, just like defining a template, right, that different users would be interacting with. Clement is not the only customer we have. So another customer would also come, also want to sign up. So now we can now say our second customer here. So you can say cost 2, right? So our cost 2 should be, so let's say equal to, then we do the same thing, first choice, right? Then we look for names. So here in this case, we can say our next customer is Larry Roberts, right? So we are going to say our first name is what? So can you see the one of the properties of class now? Should be making sense now. So class will just allow us to define a template so that we can build a program that anyone can use, right? And it will be unique to everyone using it. So our first name will be Larry. Then our last name will be what? Our last name will be Robert. Sorry. Our last name will be Robert. So we are going to say Robert, right? Then Robert's account balance. Let me look that name again so I can weigh his Victor, what do you think? I know you would have idea. Robert is a big man, $70,000 in his accounts. $70,000 in his accounts, right? So now we have been able to define another object for our class, right? I know this message will be from Victor. Okay, Robert, because Victor likes money. Robert, you're a big man now. So we have what? We have defined another object in our what? For our class templates. So in this case, we have another object. We now have two objects. So now, I was now saying something earlier. So I said I was going to make it make sense subsequently. So now is the right time to elucidate on that. So it is this underscore balance. This is what? This underscore balance. Now, I want to print Robert's last name, right? So I will say the same thing, CUST. So let me just do it very quickly. Print CUST underscore 2 dot what? Last, right? So underscore 2 dot last. So we are able to access his last name. So if I print it out, it should print Roberts, as you can see. So if you do the same thing for email, you'd also print elari.ro@firstchoice.com for him. Now, we now want to access this balance. As we are able to print Elari, we are able to print Robert. So I want to also print balance. So is it possible? So I'll say print. So the same thing, right? So let's say CUST dot, what do we have there? Underscore balance, right? So if we say underscore balance, and let's print it out. Let's see what happens. Do you notice anything, guys? It's saying that object has no attributes, underscore balance. But here is an attribute we defined here as underscore balance. But it is not accessible. Why? Because it is defined as a private attribute. Because it is something that is sensical, right? So it is vulnerable. So we don't want it to be accessible outside our program. So that is why you now use that private attribute, self.__ balance. As we wanted to access it, it printed out error for us. And this is where I will introduce encapsulation in object-oriented programming. Encapsulation. So we will be hearing encapsulation. To me, before now, I think of encapsulation and other pillars of OOP as something I need to learn differently. I'll be thinking, okay, after learning object-oriented programming, I still need to spend a time to go and learn how to write the syntax for encapsulation. I still need to learn how to know how to write lines of code for abstraction, for inheritance, for polymorphism. This this OOP, it's like it's very what? It's complicated. No, it's not complicated. Yeah, go. Okay. Yeah, unmute and speak, please.
Okay, thank you very much. I have a question, kind of.
Okay.
The private balance is not accessible by by customers. Let me just use customers. However, if while you were doing this, I kind of like added withdrawal to my init, and then so I did a method inside the inside the class and the method calculated the balance, subtracting withdrawal from the balance to get the
Okay.
total to get the total balance.
Okay.
Although both the withdrawal and the balance itself, the initial balance, are both private attributes.
Okay.
And when I printed it out, it came out. So literally, if I create a method inside the class, I can use that private attribute inside that method created and still be able to get my balance. I don't know if you understand.
Yes. Yeah, I get your question. So now, to emphasize on that, so getting like printing out balance is different from like being able to edit balance. I don't know if you understand. So
Yeah,
yeah, so what you did is you can just see, right? But you cannot edit it, right? So now, since we are dealing with money, right, we don't want to allow our end users to be able to modify their current balance, but you can be able to view it. So you can see it, which we are going to also add as a method. You'll be able to print it out and know what your balance is, which is one of the features, key features while designing a bank app, right? But as we have it here now, right? So you can't just say as end user. So because here we can actually modify our first name, we can actually modify the last name as an end user. But here, if end users tries to now change the balance, your current balance, that is where you get this error. It depends on how we are now making our program to be what sophisticated. We could just print out um to undo our error. You can print out like a customized message, like this is a restricted blah blah blah, right? So in this case, but for user to see his balance, we can write a method that will just print it out on the screen. It is just like access control. You know, like if you are working with file, so you have view only and you have what edit access. So for view only, you would believe that you for view you can see, but you can't edit. But for edit, you can see and you can edit. So it's the same thing here. If you don't have the edit permission, you won't be able to do anything on
okay,
what
okay.
your yeah. So that's just the difference.
Thank you.
Yeah. So now, so that is why we need to what introduce this private attribute, right? So in case you want to define anything that is very what sensible. So now I was not explaining encapsulation. So encapsulation basically it's what we have just practiced in this private attribute we used in our was in our in while instantiating this object. Encapsulation is simply what encapsulation does is to bundle data and methods together. So what does that mean? Let me break it down. So it's going to make sense in a moment. So I won't explain this now. I'm going to come to this first feature of encapsulation later. However, amongst other things that encapsulation does in OOP is it also allows us to build a program of access control and access restriction. So we have just done now. So encapsulation is not something that we need to bother ourselves about. While writing your program itself, you are what? Using encapsulation. It's just a feature. It's just that's why I try to make sense of them by calling them pillar. They are just like what the strong poles of what OOP can do. Yes, right? So which is what we have demonstrated now. Encapsulation, it does two things. It bundles data and method together in a class. We are going to see that in practice in a moment. Then it also allows us to what? Write a program of access control. So if you are building a scalable and secured program, right? So what you are doing in that scope is what? Encapsulation. So that is that on that. So now to now continue. So now we've been able to define our initialization, right? And after defining our initialization, we've been able to instantiate by creating objects and instances of our class first choice. All right. So now, having done this, we now want to check how this our instances or our objects can do some things, right, while interacting with our app. We don't expect them to just be able to have unique attributes, just have name, just have first class, just have first, last, balance, email. Nope, it's not enough, right? So we want them to be able to, okay, fine, when they sign in, do we have like a personalized message for them, right? So when after signing in, okay, fine. So a user wants to deposit money. How can he do that? Okay, fine. A user wants to withdraw money. How can he do that? So all these are what? Functionalities. So which I have said before, that an object is just the same thing as what? Having attributes and also functions. Now that we have attributes, what can those attributes, what can the object do? So one of the first things that we want our object to do is to be able to what? We want to define a custom greeting method. Don't forget, in OOP, functions are what? Method. Now you want to define a function that greets user when they sign in, right? So maybe after entering username, password, and clicks on that sign in button, what happens? What can that sign in button click do for user? So this is where we now define another method here and say we want to call our method greets. And by convention, every method also takes compulsory self parameter and optional parameters as depending on the requirement of your method. But in this case, we don't want something complex. We want it to be simple. We just want to greet, right? So we say def greet self, right? Then very simple. So what are we going to say here? Okay, oh, when they click on sign in, so just say that's what so just want you to just say, so let's use our F string here. So welcome, welcome who. So here, so we can now be interacting with our what? With our attributes now. Sorry. So now we can be interacting with our attributes. So we want this to be custom greeting so that when Clement signs in, so Clement sees a customized greeting that displays his name. Okay, Clement has a question. Yeah, proceed, please.
Okay, my question is that when you use the image, like a function method, is it a must we define like everything, like that balance first and last? Like, is it a must we do it in that parenthesis? Can we just like do what you did for the email? Can we just do like others like that?
Yeah, it's dependent on what the requirement is. Why we didn't include email was because what we needed for our email is first and last, right? And we knew that by generating our first and last, we can use that to what? Coin email address. So it is needless to still be repeating ourselves and still be adding email. But if it is an attribute, that is very compulsory for us to use. So we must define it while declaring our what? Init method. As I have said before, while creating an object or an instance, the first thing that will be called will be your init method. The first thing that will be called will be your init method. So it is now the arguments you provided while creating an object will be stored uniquely for that object. I hope that is clear.
Yes, thank you.
So
Awesome.
alright. Okay, so we can just to save ourselves, we can just how do I put it? We can just define everything in that in that cell, right?
You mean in the init method, right?
Yeah, in the init method, yes.
Yeah, but don't confuse it for methods. Don't confuse it for methods. So I have said before, so this is where encapsulation will make sense. This is where encapsulation would make sense. In a class, two things makes a class. The first thing is attributes, and the second thing is method. Attribute is unique. Attribute is where you define unique attributes for objects. Method is what they can do. As I said, or I cited the dog example, a dog has features of colors, right? Height, size, etc. What can a dog do? So those size, color, height, weight are the what attributes. So if you are dealing with attributes, you define it under init. But what can a dog do? A dog can run, it can sleep, it can eat, it can jump, it can bite, it can bark. All those are what? They are what? Capabilities of a dog. Those are what you now define as your methods. Does that make sense?
Yes, yes.
Awesome. So those are what you define. Capabilities are what you define as method. So we want to define our first method now. So it's going to make sense after having an idea with this. So now in this case, so we want to print out a custom message for users when they sign in. So we want to say welcome. So who is welcoming, or who are we welcoming? So what do we do here? So we just refer to our words, to our first. So we want to greet them by their first name, right? Okay, sorry, we're here. So here we say what? It's just the same thing as our string formatting, right? So, but we say self, unlike what we are familiar with, you just mention the variable name, right? But in this case, don't forget self. Self, it's like the placeholder. So it goes everywhere with you. So you now say self dot first. All right, self dot first here. So welcome, whoever the self dot first is, whoever the person is. So how what should we do? Do you have any customer representative here? How can we be of service to you today? I don't know if this makes sense, but since we are just doing this for practice. Okay, Ogushakin, yeah, go on, please. Unmute and go on.
Thank you. Why didn't we use cust.first?
Why don't I use what?
Why didn't we use cust.first?
Thank you for that question. The reason I will not use CUST is because, I said it. CUST is after creating it. For now, assume CUST does not exist. Because it's not that you are defining your class, you are creating a template that CUST will use. CUST is now the objects that will be using the template you are defining here. It is now CUST that will now come to replace this self. But now it is not that we are designing. It's just like how do I put it? I'm looking for a similar analogy. So
I
let's say,
understand. It's just
awesome.
like we need to create template first before we insert all these objects in real life.
Thank you. Exactly. So that is what it means. So now, even now, CUST does not exist. Believe that CUST now does not exist because we are still what creating our what template. Don't even imagine CUST, right? So it is now when you now create CUST, CUST now come to take place of what self is here. So self is making sense now, I believe. So now we now say what? So every time you want to greet someone, when they click on sign in, so it should say that welcome, so person. How can we be of service to you today? So now let's now go back to Ogunshakin's question. So now we would now uncomment this. So you're still going to use our first customer. Is a very cherished customer. So here we say, okay, so okay, now we don't need this again. We don't need the first name, we don't need the last name. So we have an idea of what that does. Now we want to greet this customer. All right. So now we now say what? This is now what will now be underneath that sign-in button, right? This is what will be wireframed under sign-in button. So now we now say what? How do we now access our greet method? This method, right? The function we define inside a class. So how do you access it? So it's still the same thing as what we did earlier. So you just say what? CU. Since we have, don't forget, the first thing you do is what? You instantiate. Don't forget, that's the first thing. You instantiate. If you don't instantiate, you get an error. So let me believe I have not instantiated. I just want to call it directly. And I say cust.greet. So let's see what happens. So let me run the code. You see, cust is not defined. There is no object as cust. It does not, which means this self, nothing is coming to take over from this self. Python is not understanding anything as what cust. So, but when you instantiate here, you first tell us, okay, you've created an object cust, and we have what? Data or values for it. So now you can now access everything inside that class. That's why we assigned it to this class. We want to give it access into this class, right? So we now say what? cust.greet. So let's see what happens. Let me clear my terminal. Okay, so let's see what happens now. When we run it. So can we see there? We have what? Welcome, Clement. How can we be of service to you today? After Clement clicks on what? Sign in button. Is it making sense, guys? Is it making sense?
Yes.
Awesome. So now, let's now say that we want to do the same for our second user, right? So it's still the same thing. So you just uncomment here that we instantiate it so that we can invoke the greet method. But in this case, we say print what? cust. So in this case, we cust what? 2. So now this is where objects will now be making sense. You know, I said unique. It must be unique. Now, why would it not now go and print Clement for Hilary here? Because we have an object that is unique to what? To customer 2, right? So now that is what you now declare it as cust.greet. You want to invoke greet function. Don't forget, when you are calling method in a class, if you don't add this parenthesis, it will just print the storage memory for you. Let me try it. You see what? I just added cust_2.greet. Let's see what we have. Can you see? Just print storage location for you because you are not invoking that method. To invoke the method, you must end it with parentheses. So then we can have our right information. So can you see now? So we have what? Clement, and we have for Hilary. So again, I said I was going to explain the first feature of encapsulation. It is the same thing we just did here, basically. So encapsulation is not something you just need to worry yourself about. Once you know how to construct OOP, right, you are doing all these things already. So as you can see here, it allows us to bundle both data in this case, or in this manner, attributes and methods, function together inside a class. To simply put, encapsulation. Defining a class that allows us to have both attributes and functions or methods together is known as what? Encapsulation. So that is encapsulation in shorts, right? So now we want to have another method, right? So as we have said, so we also want this method to be able to display. So I'll be fast now, right? Because this is just basically what we are familiar with. So you want this method to be able to display full name of our what? Of our user. So in case someone wants to check what his full name is, right? So this is what we can just call. So when we call it, because if you don't do this, what you can only access is first name or last name. But we should also be able to have like a capability to print out full name for us. right? So this is why we must also include it in our what program. So what we are going to do basically just what very basic, what we are familiar with, just return what in this case, we return self dot what, self dot first, right?
Mm.
So we return self dot first.
Was last.
I hope it's making sense, guys. If you have any question, please let me know, please, 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 please. So first dot, sorry, first dot, sorry, self, right? Self dot first. Then we also have what? Self dot last. Self dot last, right? So with this now, if you should call the method of full name, you should be able to print user's full name for us. So let's see that in play very quickly before we move ahead. So let's just say, okay, fine. We have all of this. So I don't think we need this one anymore. So I can clear the screen. I will also be removing this. So let me also remove this. So let's just leave our two customer example. So let's have another customer itself. So now let's say we have another customer also signing in, all right? So another customer signing in also. So we are going to say first choice, then the name. Let me look for a name very quickly. Okay, let's say Grace Uzodima. So our first name is going to be Grace, right? So in this case, Grace, right? So then we have comma, last, sorry, Uzodima. Okay, so Grace has $60,000 in her balance, right? So now we now want to check how to print out full name for Grace. So it's the same thing as we've been doing. So you just say print out what? CUST underscore 3 dot what? What is our method name? What method are we clicking on now?
Full name.
Full name, thank you. So just say what? Dot full name. So, and don't forget your closing parentheses. So let's see what we have here. So it printed out what for us? Grace Uzo what? Uzo Dima. So that is it basically. Okay, Grace. I hope you are not, I hope I included the actual amount for you. Hope that is not what you are objecting. Yes, go, speak,
No,
Grace.
no,
Please speak.
no, sorry. I just wanted to like ask a question.
Okay.
When we are defining the methods, is it compulsory for us to put that self inside the bracket? Or can it be something else, like a different variable that we put in that self when we're defining the method? And I
Okay.
wanted to ask if it's possible to return more than one, like if it's possible to return two things.
Yes, your method or function can like be complicated. You can write lines of code under your function depending on what you want to do. We are still going to see that also in a moment, right? So now, secondly, to answer your question, self is just a naming convention. You can use anything, but
Yeah.
just ensure that what you are using, it's what you use throughout your program and you are able to track it. But it
Okay.
is it is even frowned upon to use anything different from self.
Okay.
So it is like recommended to use self. They don't want you to use another thing. However, you
Or
can
can you
use
keep it
another thing.
empty, like instead of like just keep a close parenthesis, like nothing inside the parenthesis. Like let's say you don't just want to use, just keep it open.
You cannot leave it empty because this self is what you are using here as you are doing this one here. Because if you leave it, if you don't add anything here, you won't be able to call this customer to access the method inside the class. Do you get?
Yeah. Okay.
This customer now will now be okay. Let me explain it now. This is what Python is saying. Look at what Python is saying. Python will say print. You know that I wanted to explain before. I said I was going to delay it. So it's, thank goodness I remember now. This is what Python is saying. Oh. So if you say print first choice dot what? Dot, let's say full name, right? Full name. You know, full name is a parenthesis, right? And
Yes.
it takes an argument of what? Self. Then Python will now replace self with cust_3. This is what Python is saying. If I uncomment this one like this, provided I have defined an object for this class before, if I define this, it's the same thing as what I have defined here. Let's print it out and see what we have. What does it print? Still print out your full name. So that is what Python is saying. Python will now replace it with, okay, you want to print first name dot what's under first name inside the class. You want to print full name, right? So what is that full name object, which is self, a placeholder? You must, you know now, parameter, how parameter works. Parameter is just a placeholder. You replace it with what? An argument. And what we are saving as argument for CUST for both first name and last name as defined here is what? Grace and Uzodima, which means in this method now, we've been able to define two variables. So the first one is what? Self. Self is just mean myself, like saying my first name, my last name. That's what we are doing here. So we said what? Return self dot, whatever your first name is, return it. Whatever your last name is, return it. Right? So when we now want to invoke it, we now say print first choice dot full name, then in parentheses, that CUST object we created, and it's printed out on the screen. Does it make sense?
Yeah, it does.
Awesome, thank you. So now, since we are cool with this full name, then what is the other thing our application should be able to do? So I hope this is making sense and having some semblance or some attributes with what we can relate with in our what application with our bank app um interaction. So another thing we want to do is, okay, now we are now we want to be making sense of it now, right? So now we want to be able to check balance. We want to be able to check balance. So as Hilary asked earlier that, okay, fine, if we can't access it, how can we now view balance, right? After all, we should be able to check our balance. Can our application do refund? Yeah, of course it can. Of course, sure. So but your refund must be what? Must be objective, and it must be what? It must be
Of
legit.
valid reason.
It must be legit. Yeah, it must be valid.
It might be of
Because
valid reason.
it must be valid. Yeah,
That man,
yeah.
that gullible person.
Of course it can do. So we are going to do something very similar to what Victor just posited now, right? So because of the likes of those that might want to be smarter than the program you are writing, that's why as a programmer, we don't just need to understand how to develop software. We must also be very logical and also we must also be like know what is going, know what people can do, particularly in this age of cyber risk, right? So you must build like a scalable and a secured software. Otherwise, you just build a software that someone will just deposit 1,000 and withdraw 2 million, right? So which the banking sector or your clients will be at the receiving end. So we are going to introduce that also when we get to that method. So now we want to introduce another method, right? So this method should allow us to check our balance, right? So since we can modify the balance, so balance is what? A private attribute, but we should be able to see it, but we can't change it, right? So now we now say what? Def. So you can give it any name. So just give it a relatable name, check bal, right? So self, very compulsory, right? So in this case, so what are we checking? Since we are checking balance, so just say return return what? Our f string, right? So let's give it some custom message. Your account balance is then is what? What are we calling now? Can anyone try? What are we calling?
Self
What
balance. Self
we are
dot
calling?
self balance.
Self balance. Thank you. But in this case, don't forget we must still indicate it as self dot underscore underscore
Balance.
balance. So now it should be in our parentheses. Then we say self dot underscore underscore balance. So now it would now do what Robert was asking earlier. So now we have a new user, right? Grace. So let's say, hey, okay. So let's say Grace wants to check her account balance. Hey, Grace is very rich, $60,000, right? So Grace wants to check what she has left in her account. So she just do what? Print, she is customer 3, right? So you say cost 3 dots. What do we have here? Check, right? Check underscore BAL, then our parentheses. So let's see what create us. Can you see? So it's still custom. Your account balance is $60,000. So you can also add dollars. So as we all know, so it is something we are very familiar with, right? So just come here. Where is it again? So you can just come here. So just print, just add the dollar sign. So I believe we are all familiar with this. So let's print it out again and see what we have. So can you see? We now have the what? Dollar currency sign there, right? So now this would now make sense again. What I was trying to stress earlier. So now we can print balance, right? But we cannot modify balance. So that is the difference. We have view only and we have edit permission. View and edit and view only. So that is what we just did basically with self, right? To illustrate what encapsulation can also do. So another thing we also want our program to be able to do is to be able to, okay, we want to deposit, right? We want to deposit, so which is very primary to anything mobile transaction, banking transaction, right? You should be able to deposit and you should also be able to withdraw. But now we are defining our deposit method. So now for this deposit now, in this case, so we would also now be needing additional parameter. What would this parameter do? It is this parameter that will take the value that we are going to what? Supply or assign while we are depositing. It's like what? While you are interacting with your bank app, so you get to that deposit section. So you enter inside the box the amount you want to enter, right? So the variable that will collect that value for us so that we can print it out and see is what we are going to define here. So it's compulsory we add what? Another parameter here. So you can just call it amount. Let's say amount, right? So we say amount. So now we should be careful here, right? In this software, in this program, it should be smart and intelligent. You can't just come and say you want to deposit anything below 1 naira. It's not possible. You can't deposit anything below 1 naira, right? So we must also capture that. Error handling is very important in our program. So this is where we reintroduce what we are familiar with. It's basically what we've been doing before, as I've said before now. So it is not something really complex as we might have imagined. So yeah, we just introduce our words control flow by saying if what? If our amount, right? So if amount that our user or our object wants to deposit is what? It's below, let's say 1 naira, can be anything, right? So let's say it's below 1, right? If amount is less than 1, then we should say what? We should print what? Invalid or
Invalid
what?
deposit.
Invalid deposit, right?
Yeah.
Awesome. If
Hmm.
amount is Victor, you have
No,
any
no, no,
question? Okay.
no. I will come in later. Just
Okay. So now here we shouldn't just allow user to just deposit like that. No. If the amount is less than 1, which means we are allowing deposit from 1 naira. It can be anything depending on the requirement of your client. But here, for my own, you can still deposit 1 naira, but you can't deposit anything less than 1 naira. So if amount is less than 1 naira, print what? Invalid deposit. Otherwise, print what? Otherwise, we won't print. Then what will now happen? Otherwise, this is now where we will now say that what? Self, pay attention here, please. Self and this balance, it goes everywhere with its private what? Convention. You know, say self dot underscore balance. What do you have? Why are we not adding the deposit amount to the constructor to avoid having two parameters in the deposit method? Okay, so the reason is I just want to use this to demonstrate extensive method usage, right? So, and also to introduce some control flows, and also for methods. So basically, since this is just like what an interaction, deposit is not a feature. You know, I explained it before. I said a class or OOP, basically it is just what allowing us to have attributes and capabilities. Depositing is not an attribute. Depositing is an action. Like, you understand? If you want to deposit, you are interacting. It's like a capability. What our application can do. It is not what is unique to a user. After we have a customer, what can a customer do with us? A customer can deposit with us. That is why we cannot define deposits as our what? As our as our instance variable or attributes. So
Okay,
that is
it's
why we
just
need to.
sorry. Just to understand, it's just like, let's say maybe you have like noun and verb.
Okay.
Verb is an action word, which is like capability, so what something is doing.
Yeah.
And now is the attributes. Now
Thank you.
is what like more like a feature of that
Thank
particular
you.
software we are
Thank
building.
you. Thank you. That depicts it. That is a very good representation. That's a very good representation. So we have what tells us what a person is and what a person can do.
don't go over.
So you have a new title, Ogunshakin.
Of
You can meet us later for
quotation.
your you get. So we'll be doing that later. So Victor, so you are the planning committee for that. So now
So
we say self dot underscore balance should be now be equal to what? So this is where we now do just a basic arithmetic. So I'm trying to introduce. So the reason I'm even doing all of this is just to introduce some of the things we have learned in the past, just as refresher. So it's just like a basic arithmetic. So you want our input to be an integer, right? So don't forget, just say what self dot balance should now be what? Should be self, since it's deposit, right? Deposit should be what you have already and what you are just what adding, isn't it? And what we have already is what self dot underscore balance. Then we want to add it to whatever the new amount is. Then we now say what amount. Does it make sense? This is how you build deposit basically. Though it can be complex and it can be robust. It can be more robust. there could also be other requirements, but basically this should also capture our deposit function. What are we doing basically? Just a basic plus and minus. We have something already as self dot underscore balance. Then we want to add anything we collect as amount argument here to it. Then it should be stored as our new balance, right? So then when we now check balance again, it should be able to return what our new balance is for us. So let's check this very quickly before we move ahead. So let's say we have is the int compulsory? Yeah, it is because it just depends on what you want to have, right? So maybe you want to have a whole number, or maybe you want to have you don't want to have a float. Do you get? So it's just dependent on how you want it. So as we are familiar with typecasting, do you get? So if you don't add it, it would also work, right? Just depending on what you want. So, and we also want to be careful on what we get from users, right? So that everything can just be typecasted into int, because we are dealing with calculation. That is why we are adding the int. So it depends, just like dependent on what the project's objective is. So if it's something else, maybe you are dealing with string. We have done concatenation before now. So where we fetched email address, we didn't add int because we knew we are dealing with strings, right? So that is that basically. So now let's see now how this how the user experience is with this. So let me clear this. I want to see the user experience now. So okay, fine. Now let's see if we can. Okay, it's fine with this. So our Clement user, so Clement eats jackpot, right? Clement eats jackpot. So Clement is now bringing the money for us to save. So Clement wants to save. So since we have Clement already, Clement will just say that what Clement, we've declared Clement as object. So we just call Clement object, which is CUST, that will be replacing the self, right? Dot what? Deposit. Does it make sense? Dot deposit. Then the new amount Clement is what? Depositing. So in this case, Clement is depositing 5,000. And already Clement has how much? Clement has 50,000, right? So you just say what? Enter. Nothing happens, right? Now let's print Clement's new balance. So don't forget, we also defined another method to return our balance. So in this case, we just say what? CUST, which is for Clement, right? Unique to Clement that we are working with now, dot check balance, right? Then don't forget your parentheses. So now let's see how much Clement has now. Can you see? Okay, we still printed Grace. Let me comment out Grace. This is what I'm going to do so that it can be visible. Let's visualize. Where is Grace? So I'm going to print out, I'm going to comment Grace, right? I'm going to comment these two. Then before Clement deposited, let's see how much Clement has, right? So let's check Clement's address, amount or balance before he cashed that $5K out. So we'd say this, right? So let's see what he has, then what's it amounts to after the new balance. So let me just drag this up. It's not printing out the old amount. One moment. Let me comment this out. So before we added, how much does he have? Can you see? So Clement has $50,000, right? So now Clement is now depositing $5,000, right? So how much does Clement have now? So our addition should be able to what? Do that for us. So now your account balance now is what? $55,000. right? So that is that basically for deposit. So very quickly, any question?
Yes, yes. I have a question.
Okay.
Why do you want to
You are
have
not
our
audible. You are not audible.
Can you hear me?
Okay, I can hear you now.
So why didn't you print out the initial balance for the deposit?
The initial balance before the deposit.
Yes.
So here we have it here. So we want to check the balance before deposit, right? So can we see it here? So it's just misbehaving before. So before now we have $50,000. Then after the deposit. So this is what we just did, basically just simple visualization. So we print out how much Clement has before, right? So we can see or confirm that he has $50,000. Then we deposited 5,000. Then we check the balance afterward. And now we can confirm he now has $55,000, right? So that is that basically. So now the next thing is withdraw, right? You won't just be depositing money. You would also want to what? Withdraw your money. So how can we define this capability also in our what? In our mobile application? So it's still the same thing. So you just come and define another method to represent withdraw. So in this case, we call it what? Withdraw. So trying to use related word. So don't forget your what? Yourself. It is very important. So then we say what again? Our what? Amount again. It's also important to add it here, right? Our amount also again. So now we also need to be very careful and smart here, right? Because someone could have $5,000 and want to withdraw $50,000. How do we undo that as developers? So it is very essential we take notes of this, right? So this is where we can now say that what if amount that he wants to withdraw is what is greater than what?
Balance.
Self dot underscore balance. Thank you. Right? So what do we say? We are all familiar with this. Only Victor that cannot relate to this. We say what? Print. It's only Victor that cannot what? Relate to this. We say what? Print insufficient balance. Do we get insufficient what? Balance. Anytime you want to withdraw anything that is more than what you have as your current balance. So you should print out incorrect balance. Else should now be what? Else we will now do what? Another what? Mathematics here. So you just do self dot underscore balance should now be equal to what? So we remove it. So here it's the same thing. It's the same thing as saying it's the same thing as saying this, right? Amount. Who is confused? So what we just said here is the same thing as saying self dot underscore balance is equal to self dot underscore balance minus amount. If this is confusing, so let me just use the normal convention so that we can still use our words. So let's just say it. So we say what? Self dot underscore balance, right? Then minus what? Amount, right? So now we've been able to what? To capture our withdrawal method. So now let's now say we want to create another user. So the reason I'm creating users, I am driving at something. So because now the next thing I'll be introducing is class variables. What we've been dealing with so far is instance variables. Instance variables are variables that are only unique to users, right? They are unique to users. They are unique. Every user we've been created so far has his or her first name, last name, and email address. But what if we also want to have a capability that should be able to do something that can be shared amongst users? So that is where you need to use class variables. how do we use class variables? We are going to be reaching there in a moment. So I will create one more user here. Okay, so here we are going to use Motolani. Motolani doesn't have second name, so we'll be saying here we want to create another user, right? So it will be our what fourth object. So Motolani will be our fourth object. So we say CUST4, right? So should now be equal to, so it's still the same thing that we've been doing, right? First choice, then first name Motolani, right? Then comma, then guest. I'm sorry, Motolani. So she has 80,000 in our account, right? So I think we are cool with that. So now what we want to do now, what we want to do now is we want to be able to also have a method that can apply interest for all our customers. So, and this interest, we want, since it is the same interest rate, so we can't really, we shouldn't disturb ourselves by having something that is unique to each user. I don't think if that makes sense. Does it make sense? Does it make sense, guys?
Yeah.
So what we are doing basically is we want to have another variable now. What we've been dealing with so far, last name, first name, email address, they are called instance variable. But now, one moment, please. I want to plug my system. Give me a moment, please, guys. Just a moment, please. Just a moment, please. Okay. So, as I was saying, what we've been doing so far are unique attributes. What if you want to have shared attributes? So shared attributes like an interest rate. Logically, we would all think of interest that is the same to be shared amongst what? Amongst all created objects. So let's say we want to have like a 5% interest for all our customers who are our what objects in this case. So now what we need to do is to first define, we can do something like this though. So we can say def, so we use this to apply interest, right? So let's say we use this to apply interest. Then we say def underscore def apply underscore interest, right? So we can now say in this case, we also return ourselves, right? Self will be returned. Then this is where we now calculate the interest. So what interest are we giving our users? So let's say we are giving them 5% interest. So it's something we can just say self dot balance, right? We are still applying it on the balance. So it should be equal to self dot balance should be equal to what? Self dot underscore balance. Then I forgot my int here. Then multiply. We remember, right, how to calculate interest. Multiplied by, so 5% is what? 1.05, if I'm correct, isn't it?
Yeah.
Awesome. So now, if we check now, so let's check. Let's now say our new object, Motolani. So she is now eligible for this interest. So she now wants to check to confirm if she has received her interest or otherwise. So we can just use this same one we have defined here. So let's now say, we now say what? Our CUST what now? If you are checking for Motolani, so we are checking for, which object are we checking for? Can anyone confirm?
Oh,
4.
Oh, thank you. So our CUST4 dot what? What are we checking for? Apply interest, right? So just say
Apply.
dot apply interest. Then we don't need this, so we remove this one, right? We don't need this too. So we comment out this. Okay, let's leave this so that we can check what our before and after balance would be. So in this case, let me clear this first. So then let's print it out and see if this works or not.
No, you have to edit it. You have to edit it. It's printing Clement. To
Oh,
put Clement.
sorry. CUST4, right? So print also should still be CUST4. So it should be fine now. So can you see, before the interest, she has $80,000, which we can confirm as our balance when we instantiated our object. But after applying the interest, she now has $84,000, which is 5% of $80,000 if we do the mathematics, right? So now, yeah, we can actually do this. It is fine. We also we are still able to achieve our what aim, right? But what if you now want to check something like, let's say, and I want to check what the interest rate is. Maybe I have written lines, like multiple lines of code. I just want to check here. And I want to check here what my interest rate is. So let me comment this out. So I can't check here anywhere and confirm what my interest rate is. I can't confirm, right? Why? Because I don't have any variable that is keeping that data for me, right? I don't have any variable that is keeping that data for me. And also, I don't want it to be an instance variable because I am defining the same interest rate for all my objects. So this is one of the reasons why we can use a class variable. So how do we now use a class variable? Let me check what we have in the chat before I proceed. Yeah, sure, Clement, sure.
Okay, yeah, thank you. Sorry, I'm sorry. That withdraw all these terms, I do forget.
The withdraw method.
Yes, the withdraw method. When you use the else, the
Yeah,
self dot and ask corner for balance.
okay.
Like that's minus
Oh,
the minus equals to. Okay,
oh. Thank you for that pointer. Thank you for that
okay.
pointer. Yeah. So yeah. So I was using a different syntax before
Yes,
I had
yes.
to use this one. So I forgot to take that out. Thank you for that pointer. So now in this case, we now want a class variable. Since this is general to all our objects, everyone is getting 5% discount, right? So what if tomorrow I want to increase it to 10% discounts? All this can be easily done if we have a class variable. So you just come under your class here. Can you see where I'm defining it? Under your class here. So you can now define something like what? Interest. Take notes, guys, please. So you define what? Interest. So now we are defining a class variable. So this one belongs to all the objects now. They share it. Every object can access it. And it is the same for all objects. So any object that is eligible for this interest, right, can access the rates that I'm setting for the interest. So now, but I'm saying that the interest should be what? So since we have 5%, so just say interest is equal to still the same thing, is equal to 1.05, right?
No, if the interest is 5%, it is 0.05.
Is it 0.05?
Yes. 1.05 is 10.5% interest.
Are you sure?
No.
Okay. Can we confirm, please? Can we confirm, please, very quickly? Let's confirm, please. Let's confirm, please.
Interest.
Can we all confirm, please?
Yes, 5% 0.05.
You can't give them 105% interest on money that you get the loan to. Let's say,
So is it 0.05 or 1.05?
0.05.
Okay, 0.05. All right. So 0.05 is what? 5% of our 5% interest, right? So that is declared, that is covered. So now let's now proceed and say that. So now in this case, right? So we now come back to where we've used it here, right? So what do we return here?
interest.
Do we just say interest?
Say,
Do we just say interest?
yes, because
Okay.
it wasn't
So now
defined.
let's see what happens if we just say interest.
Wasn't defined as an initializer, I think. Don't know.
Okay.
Just saying, man.
Let's see what happens if we just say interest. Can you see what happens? It's not recognizing it. Why is it not recognizing it? Because if you are dealing with class is just like a representation. Don't forget, we are saying it is what? A class variable. So you must reference it with the class it belongs to. So in this case, we need to say what? First choice. The class, we define the class here. First choice. Oh, what am I doing? First what? Hope I have not pressed Control spoil. So first choice, what? Dot. What happens then? It cleared that flag. Do you notice anything? So in OOP, you need to like be very conscious of how you call your variables. Yeah, go on, please.
Okay, yeah, thank you. I literally understand everything, but now this, I don't know, this is not kind of like question. It's like I'm trying to clarify something. Can you like scroll down to the initialized variables, the init method,
Scroll
sorry.
right or scroll up.
Oh, sorry, my
Okay.
bad. Scroll up. Okay, so if, for example, the interest is applied to a certain members of the bank, like people registered for a particular thing. Let me see, for example, current account members. Now, I think, I don't know, what we'll do is literally just initialize a variable under the init method and kind of like a boolean, kind of like that says registered, a registered boolean of true or false. So if the person is registered, it triggers the interest. I don't know if that's how it will work, because sometimes this interest is not given to everybody in the bank, but to a certain registered members for a particular store or something. I don't know if you understand what I'm trying to say.
Yeah, I get your point. So it is valid. However, so why I'm applying it to all objects is to introduce class variables. So while I was explaining or introducing class variables, I said that class variables is like a shared feature amongst objects. So, and I think it makes more sense to use it in this sense that it should be applicable and be the same for all our defined objects.
Yeah, that's what I'm asking. I know what you're trying to do. I'm asking now that if it's to a certain number of people, to a certain set of people, what we'll do is it that will like kind of create a, a variable under the init.
Okay. Yeah,
Yeah, it's kind of like, yeah.
Exactly. So you can do that. You have two options, right? So if you want it to be unique, if you want it to be unique, you can also define a variable under init, right? So that would work. And also another thing you can also do is here. So where we have it defined as first choice dot interests, right? You can also say if you want to tweak it amongst objects, if you want it to be unique amongst objects, you can now say what? Instead of first choice, you can now call it as self. It would also be accepted. So even with this, you don't need to define it in your init again. This
Okay.
also suffice. Yes, you would.
Yeah.
It would make sense now. So let's check an output and see what we have. So now we say what self apply interest, right? So now we want to check interest for before we do it, before we apply the interest. Let's check what our interest rate is. So you can say here print, since it's a class variable, right? So we call it as first choice dot interest, right? It's a class variable. So we want to print it out and see what we have. Then after then, we now apply it to one of our customers. So let's say cost4 dot what? Apply interest, right? Apply interest, right? So then so now in this case, I now want to change it. I want to change it for cost4, right? I don't want. So that was one of the things I was saying earlier, that if you just like define it without a granular scope, it would be very difficult to tweak or modify it, right? It's very difficult to tweak or modify it. You need to go back to where it is being hard coded before you'll be able to change it. But in this case now, you can even say that since it is declared as at the top here, we said 5%, right? So yeah, you can even say if you want to change it to 10% here, you can say first choice dot interest should be equal to what? 0.10 should be 10%, right?
Yeah.
Okay, so now here you can like modify it. So now what we need to take note here is anytime you are invoking the class, if you are changing using the class instance, you are changing using the class instance, right? In this case, the class variable, all the changes will be applicable on all your objects. So in this case, let's print for 2 users. So we are going to apply this new rates for our cost4 and our cost2, right? So dot apply interest. So now let's now see what we have now for cost4, and cost2 dot check balance. Okay, so now before we change it, let's see what their balance is before we make the modification, so that all this can make sense. So I want to point out something very important here. Before we make this new adjustment, so we have this for cost4 and we have this for cost2. Okay, so then afterward, we now change the interest rates to 10%, right? So we don't need this for now. So you can comment this out. So then after changing it, we now apply what the interest rate is. So here should also be, we should apply it first. So we should apply it. We should apply for both of them. So we are going to apply for cost2 also. Okay, so we apply for them for both cost2 and cost4. So then we print it out to confirm. After then, we now change the interest rate, right, to 10%. Then we apply the new interest rate and we print it out again. So let's see what we have here. We have invalid syntax. What is invalid here? User line 1. What is happening in line 1? There's nothing wrong with our line 1. First choice, interest. What is it flagging? Everything seems fine. Oops. I hope this
Close
my
the
VS
terminal
Code
and
is
do
not
it again.
starting. We would lose all this file, right? Okay, it's saved. It's
Just,
saved. Yeah, it's saved.
just close. No, not
Yeah.
this one. Just close this terminal down. Like
You
this
said?
one down. Just close this terminal
Okay.
down. Yes. Mm.
Okay. So as you can see here, right? So I think it's still misbehaving. Your account balance is no one has 4,000 as their account balance. Does anyone have 4,000? We didn't declare any account balance as 4,000. Let's check again.
Let's check the code.
Okay, let's check our code. Has anything happened to our code? It's still bringing a different thing again.
No, in the print section.
So, okay, this is what we have here, right? So we have 4 objects, right? So we have the first object, 50,000, 70,000, 60,000, 80,000. So we now want to apply interest for customer 4 and customer 2. So we want to check what's their initial, okay, their previous interest rates. We want to check what it is.
The thing is right. What the output is right, because if you do like if you do the 0.05 multiplied by the 80,000, it will give you 4,000.
Is it correct? Okay.
Yes.
Okay, so if it's correct then. So we have been able to demonstrate what the new interest rate is. So as you can see here, so before we increased the interest rate, right? So we had the initial interest rate. Then we were able to come here and modify it to what? To the new interest rate. Then we apply it and we check our balance. So that is one. Also, now I would like to address Larry's point here also. So now you can also now modify for specific users here in this case. So in this case, if you don't want it to be for all, we don't want it to be for all objects here. So you just come here and say what? CST4. So let's say it's only CST4. We are trying to upgrade our own interest. So you just come here and say what? CST4 should be equal to CST4 dots. Don't forget, why we are able to do this because we used self.interest here. If you had used first choice.interest to not allow you to be able to change specifically for an object. But this is one of the benefits of self here, right? With self, you can change both as a class and you can also change both as what? An instance, right? So you can now come here and now say what? Cost.for.interest should now be equal to then we set the new rate 0.110. So now this would only be applicable to customer 4 if we print it out, right? So now let's now check. Let's check. This is what we are going to do here. So let's check what interest rate is for everyone now. So let's check what interest rate is for customer 4 and customer 2. So we are going to say, so here we are printing interest rates instead of balance. So we'll say what here? We'll say customer 4 dot interest, right? So then customer 2 also dot interest. So we can check if this is applicable uniquely or generally. Okay, so now let's see what happens if we print. So what do we notice here? For customer 4, which we modify for uniquely, she's having what? That 10%. See, customer 2. Customer 2 is still inheriting the class variable that we defined at the top. That is why customer 2 is having 5%. I think this answers Hilary's question. Does it?
Yes.
Awesome. So we are able to what? Modify uniquely for a specific user. However, if we had come here and now say that, sorry, if we had come here and say that first choice dot interest, this would not allow us to track it for specific object scope. So that's why we can just leave it here as self, so that it can allow us to just do anything we like. So this would like be flexible. So this one will be flexible, right? So that is how we can use class variables. So this is one of the unique importance of class variables. So it allows us to modify the interest or the value or the data we want to be general for all our objects. So I will also introduce one other important use case, for a class variable. So in this case now, so another thing that would also require us to use class variable is, let's say for instance now, we want to audit. We now want to know, or we want to know at the moment how many customers we have. Do you get it? You want to check how many customers we have while auditing. So now, if you want to check something like that, you would all agree that it does not have anything to do with unique attributes, because we are checking for all the customers that we have already, right? So in this case, it is sensible to use a class variable. So we can now declare the variable here. Anytime you want to declare a class variable, so you must declare it under your class definition. So we can give this variable a name and call it what? So here we can say cost count, right? So you can say cost count. So we will give it a default value. So let's set it to 0, right? So set this to 0. So this is set to 0, right? So now, since this will be counting immediately after initialization, don't forget, what you want to count is as soon as a user clicks on register, you want to know that, okay, we now have a new customer. So that should tell us the position that we should define our counting, our counts, right? So in that case, the count should come under init, because after the first object registered, we want to count it. After the second one register, we want to count it. After the third one register, we want to count it, right? So that is why we must define it under this. Then to do that, we also use this. But in this case now, now in this case, you can't use that self scope because it doesn't make sense. We are not counting a single user. We are counting all our users. So in this case, we use what? Our first choice dot cost count is equal to cost count plus 1, which is the same thing as what? So which is the same thing as saying is equal to cost count plus or equal to,
1.
thank you. So it's the same thing as saying blah, 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 first choice dot cost count is equal to first choice dot cost count plus 1. So it's the same thing. So now let's now check if this works as intended or not. So now we now want to print how many users do we have now? We have 1, 2, 3, 4. We have 4 users, right? We have 4 customers. So now how do we now check if to not know the numbers? Let's assume we now have like hundreds of users. We have multiple users. You can't be counting manually, right? So you can just call that class variable we defined above and say here that what? First dot what? Very simple. First dot, what do we define it as? Cost
Cost
count. So we don't need all these ones. So let me just comment out all these ones. Okay, so let's print and see what we have. How many do we have here?
4.
We have 4. So let's count 1, 2, 3, 4. Can we see? So this is another use case for class variables. So again, class variables are very handful and instrumental when we are dealing with what a general feature or a general attribute for all the objects. So as in this case, we just want to count everybody. So it shouldn't be unique to anyone, right? So that is that on that regarding this variable. So I think to an extent, we've been able to capture a lot of things this our bank app. So another thing also I would also like to introduce is also as we have class variable, we also have class method. It's also important. It's also like important concept to understand in OOP. We have class variable, we also have class method. So how do we use class method? So in this case now, so let's assume we want to do modification for any of these variable we've defined above, right? So with class method, it would make it very easy for us to do, right? So here, to now use class method, so it is just, this is the syntax, right? So it uses what we know as a decorator. And the decorator is, you say what, at class, its function would make sense in a moment, right? At class method. That is the decorator. At what class method? So what this is saying is anything under this method, treat it as a class. Don't treat it as instance method. All these are instance method. Check balance, deposit, and the likes. They are instance method. But everything are defined under this at class method decorator. Treat it as what? As a class method, right? Now, let's now say we want to define this method that we can just be calling every time we want to change this interest rate. Every time you want to change this interest rate, maybe tomorrow it increases. So you can just call this method and use it to what? To modify the interest rate. So this would allow us to what? Use this class method because the the rate is what? A class variable. So in this case, we now define again. So after that, you use the same thing, the same convention, and say def dot, you can now say set interest. You can call it anything, right? So just that it can still what? Attribute or affiliate with what we have been what coding all the way. So now something also important, we need to take note here. Let's pay attention, please, guys. Here also, before now, by convention, every time we are defining method, we use the words self, self, self. But here, it would change. What class accepts as its own first compulsory parameter is CLS. And this CLS don't allow it or don't enable it to what? To confuse you. It's still the same thing that self is doing. It is now what? It is this one that will be calling back to call back to our class. That is what we are doing basically. Every time we are trying to use the class to change these interests, right? It will refer back to the class name. So it is just representing the class name. So it's known as what? Set. So then set, then it takes another parameter. So the other parameter is what will take the new value we want to use as our what? As our rate. So this one would be the new rate. So in this case, we can say new rate, right? So you can just say new rate in this case. Then that's all, right? So now we now do the same thing that we are familiar with. So you just say CLS dot what? What are we calling here? Interest. Do you get? So we are going to call our class variable here interest. So you call interest again and say CLS dot interest should now be equal to anything we enter as the new rate. Does it make sense? It's still the same thing we've been doing. Any question?
Why not new rates?
You said?
Why not new rates?
Why not new rate? Do you mean CLS dot interest?
Yes.
Yes, it's because what we are modifying is our class variable here. So we are defining a class method to act on this variable. So that anytime you want to change this interest rate, we can just call it and put the new rate there. So that is why we need to refer back to this interest. So that is where we now said here that CLS dot interest, current interest, should now be equal to the new interest. That is what we said basically. Anything we take as the new what interest here, as the new rate here, should now be our current interest rate. Then we refer to it as what CLS dot then interest. We are working on interest. Don't forget here, because we are working on balance. What did we call? We call balance. Do you get? We want to apply interest here. We call balance. When you want to deposit, let's do a recap so that it can make sense. When you want to deposit here, you want the deposit to act on our existing balance, right? So anything they are just adding plus what they have should make us the new what balance. Now also here, it's the same thing we are doing. It's the same thing basically. We have our interest rates set to 5%, but we want to have a method that would allow us to just like call it anytime and change it. Maybe a user has now upgraded, right? So you now want to give this new eligible user the new interest rate. So you don't need to be coming into our code and be add coding or be going to the top of the program and be changing from 0.5 to 0.10 or as the case may be. That's why we are now defining this method. So anytime we call this method, we can just say interest is now equal to 0.10 or 0.20 or as the case may be. Does it make sense now? Hello, does it make sense?
Yes, please continue.
Awesome.
Yes.
So now let's now check how this works. So now we can now come here. So it's something we've done before now. So but we just need to also visualize so that we can. It's the same thing as what we did here. Let me find it. Where is it? Print, apply interest. So it's the same thing as what we did here. So it's the same thing as what we did here, right? But now instead of it being unique to, it's the same thing as okay, let me clarify it. It's still the same thing as saying that. So now I can just say one moment. I can just say now that first choice dot what is our, what do we call it? We call it what? Set interest, right? So you now say dot set interest. Before now we had what? 10%. So now let's now say we want to have 12%. Does it make sense? It's the same thing as this. It's the same thing as saying that the same thing as saying first choice dot interest should be equal to, but now we are making it a method, like should be able to perform an action. In this case, we want to enable it to perform what? An action in this case. So that is why we now define it as a class method. So every time we just call it, so we just refer to our class dots, then the method that we set, which is set dot interest rate, right? So we now want to set it now to 12%. So if we check, so now let's now say before we set it here, we apply, before we set it, let's say before we set it, we apply this interest rate for customer 2, right? So this one would use the former interest rate. So now let's now see what the customer 2 interest rate would be prior to when our account was upgraded to now be taking 12%. So now we now say we want to check customer 2 account now. So let's uncomment this. Okay, so if we check this now, can we see? So now let's print it out now. It will make sense. So do we see what we have here? What am I printing? This is not what I'm supposed to print. I'm supposed to print the balance, not this one. So this is printing the interest. So let's print the where is the check balance for customer 2? Let's use this one. Just change it to customer 2. Customer 2 dot apply interest. So we print customer 2 balance, then we change customer 2 interest to 12%, then we print customer 2. It shouldn't be giving us the same thing. Let me delete this thing and try it again. So let's run it again. It's still showing the same thing. So we changed the interest rate here. So here we have we are changing it to first choice dot set interest to 12%. So initially we had how many percent? Initially we had 5%, right? 0.05. Then we want to change to 12%, 0.12. Then we want to print the former, then apply. Okay, we didn't apply. After changing, we didn't apply. So I just printed it out. So we need to apply. So let's now use this one to apply. So we need to apply here, right? So customer 2 dot apply new interest rate and print the new interest rate. So can we see it now? So can we see? So we are able to what, just do the modification by just invoking the class variable what that we defined. So we don't need to be at coding and be coming all the way up here to what, to be designing or to be changing data. So you can just do that and achieve it inside our what, our class variable. So any questions, guys, so far? Any questions so far?
So in every class method, we are to
Okay.
apply CLS, right?
Yes, for class method, yes, we use CLS. But for instance method, we use self. But basically, they like function the same way. So just naming convention that differs.
So the class method I use. I don't know. Really call like the call. I
Your
disconnected from
voice,
the call.
your voice is not clear, Clement.
Can you hear me? Can you hear
Yeah,
me?
I can hear you now. Yeah, yeah.
I said by call. You know
Ah, I can't hear
sorry.
you, Clement. I can't hear you. Can you type in the chat? Type in the chat.
Even has swallowed his mic.
Type in the chat. We still have 2 more concepts to check, but I'm checking time. So I'm thinking we would need to postpone this to our next session. So because we still need to also check, but you can do it. I'll just be very fast. So I can know we've summed this up. So in our next session, we can be checking another thing. So I still need to elucidate or go into I didn't really understand the class method because I got disconnected. Okay, so let me reintroduce class method. So I'll be fast. What class method does is, you know, if you now appreciate what class instances are, right? If you appreciate what class instances are, is that we can call the class? Yes, exactly. That's the logic. That's the logic. That's the logic. So that you can make changes to the class everywhere. So all you just need to just check and be familiar with is just the syntax. So the first thing is use the decorator at class method so that it can tell it apart from ordinary instance method. So when Python sees at class method, it's understand that what is coming afterwards is the class method. Then the next thing is you just give it what you define your method and what give it a name. You can give it any name. But another difference it has with ordinary method or regular method is it takes CLS as its own first parameter. It is this CLS that will now link or connect to your class. It is this CLS that will connect to your class, just as the same way self connects to what, to anything you are adding as what, as your argument. So that CLS will now connect with your class. Then followed by the new value you want to change your rate to. So now you just say what, CLS dot, in this case, interest should now be equal to what, the new rate. So anything we are adding as the new rate should now be equal to. So then when we now invoke it here, so as you rightly pointed out, Clement, so we say what, first choice dot, then we say what, we now call that set interest. We now want to set it equal to, so this CLS will replace first choice, then this new rate will be replaced by 0.12. I hope it makes sense now.
Yes, thank you.
Awesome. So now the next thing would be brushing now is, so I'll be very fast now so that we can achieve the objective of this session. So now we'll be delving into inheritance. In this inheritance, so I'll be also facilitating abstraction in OOP. So we've been able to check encapsulation. So now, while introducing inheritance, we would also be checking the other pillar of OOP, which is abstraction. So what is inheritance basically? So inheritance, it's not far-fetched. It's just like you being able to reuse codes, or you being able to reuse programs that you have defined in your parent class. So inheritance will give us a scope whereby we have a parent class, or as it is fondly called or referred to as superclass. Then also we have what, a child class. So it's just like a parent-child relationship. So now let's say, for instance, now, how do we know we are to use inheritance? How do we know we need to build this relationship? So let's say, for instance, now, in this program, we now want to have some customers as our exclusive customers. Do you get? They are still customer, right? But we want to have them as our exclusive customers. So exclusive customers, they will be requisites for you to be an exclusive customer. However, in our own program, we want to be able to keep track of whom our exclusive customers are. Then we also want to now have a subclass of managers. These are not regular customers anymore. They are now managers. But these managers would now be responsible for keeping track of whom our exclusive customers are. Now, for managers, we understand that managers also need to have unique attributes. They should also have their first name. They should have their last name. They should also have their they should also have their email address, and they can also have their deposits. They also have like an account with us, right? But they want to have a new field, a new attribute. So in their own new attribute, that is the attribute that will now be storing the exclusive customers. Each manager is what handling. Does it make sense? Is it making sense? So what we want to do basically is we want to have the same features, right? But we want to have the same features, but we now want to have an extra field, right? The extra field should now keep track of each exclusive customers that each manager is managing their accounts. However, we still need our managers to have the first name, to have last name, to have their own account balance. But in addition to all of these variables or fields or attributes we will be having in our parent class, we also want them to have an extra attribute, which is which should be keeping record of each exclusive customers they are managing. This will make sense now in a moment. So now in this case, we would say that we want to define a child class. right? So this is inheritance. Inheritance simply will just inherit all the attributes and methods in the parent class. It would inherit all the attributes and methods in the parent class. So we don't need to now be redefining or to be declaring new methods or new attributes again in what? In our child class. So we just inherit everything with what defined earlier in our program. So it will make sense now in a moment. So now the syntax is just what? You just say what? Class. Then since we are defining this class for managers, we say what? Managers, right? So now how does Python now know you want to inherit? So this is where you now include it. What are we inheriting? Our parent class, which is what? First choice. So does it make sense? Let me know, please. If there is any confusion, please let me know before I go deep. Does it make sense? Let me know, guys, please. Does it make sense?
Yes, yes, yes.
Awesome, awesome. Thank you. So now this is the syntax to what to do anything inheritance. You define the new subclass, then you assign it the parent class. When Python sees this, you understand that you want to download all the functions, all the attributes, and all the methods you have in this parent class. You want to make this child class have access to everything. So now that is it. So now the next thing is now you now say what? You now say that, okay, after this, you now define init, right? You define init. It's now take what? Also self. Let's pay attention to this syntax. So self, then don't forget we have first, right? We have first, right? So if I can still remember, we have last, right? And we also have what else do we have? Balance, right? We also have
Yes, balance.
balance. Thank you. So now we also have balance. So now in this case, we now want to introduce another attribute or another field. And this is the whole reason why we are defining a subclass. Because like there is a new model we are trying to introduce into our what business operation. We now want to take some users as exclusive users, right? And we want to assign them managers that will be managing their accounts. However, these managers also, since they are also staff, so they also have their name, they have their last name, they also have an account with us, they have balance. However, so this last attribute is now where you want to store users that would be our exclusive users. So which means the manager class would now have an addition field, which is what exclusive. So we now store this exclusive, we save it, we use default argument. Use default argument. So if you are still if you still have confusion on this default argument, you can revisit the session we had on functions, right? So this is well it is explicit in that episode. So I want to be very fast now because of time. So we now said what exclusive is equal to none. Why am I using exclusive as none? Is because I want to set these exclusive members. I want to store all the elements inside a list. Because, when I was facilitating lists, I emphasized on the fact that a time will come when you'll be dealing with large data sets, right? So you need to have a data structure that would allow you to keep track of all the data you are collecting. So in this case, for my exclusive members, I want to ensure that I have a structure to keep their records. And I am using list as my data structure here. This is why I'm defining exclusive as none, right? So after that, we now say that what? So the next thing that now followed is now, you remember when we were declaring or defining this parent class instance attribute. After declaring the init, we are now saying self.first is equal to first, self.last is equal to last. Are we expected to do the same thing here? If you are doing the same thing here, then inheritance does not make sense. If we are inheriting, we shouldn't like be repeating our code. So what happens to DRY as Python convention? Do not repeat yourself. We don't have to do that. So that's why we now do the next thing to call on all the things we've defined earlier. We now say what? Super, then in brackets, dot underscore underscore dot underscore underscore init, right? Underscore underscore. Then we just say what? First, last, then what? Balance. Does it make sense? So what we just did here basically is just the same thing as saying self.first is equal to first, self.last is equal to last, self.underscore underscore balance is equal to balance. But we are now inheriting it from our what super class. Since we defined that, we don't need to be doing all of those again, right? So that's what we just did basically there. So, but we won't do the same for the new field we introduced because we didn't define this one. Python does not know this one as what? As a parent variable. So this is why we now need to come and define this one separately. So we can now do self dot exclusive is equal to exclusive for this one because we are just introducing this as a new field. However, since we are using lists, so we won't just declare it. We just declare it plainly. We still need to capture some error here so that we can know that everything I am collecting, all the exclusive customers data I am collecting, I want to store it inside a list. Then you now introduce another control flow here. You say if exclusive is what? Is this none that we set it to here. If exclusive is none, that we set it to, right? If exclusive is none, that we set it to, what should happen? Then we should say that self, right? Self dot exclusive should now be equal to an empty list. Does it make sense? If when we are defining or invoking or creating an instance of a new manager, if we don't get any exclusive member here, then if you want to call our exclusive instance, then you should, if there is no value or data, then you should return an empty list. Otherwise, if we have, by the time we created a new manager, then we have a new exclusive customer here, then we should say what? Self dot, then we now say our usual exclusive should be equal to anything exclusive. Does it make sense, guys? Okay, I will recap this very quickly. So what we are doing here basically is just normal thing we've been doing, right? So because we are using lists. So we are saying that if we don't get any arguments, any value provided here as exclusive members, just return an empty list every time you want to call on our what? Exclusive instance. However, if there is a value here, we define a new object for manager, and that manager has a new member as his or our exclusive member, then make that new exclusive member as our what? Exclusive. So that's what we just did here, right? So what is that thing basically? So we've been able to what? To define what? An init method for our what? Subclass, for our child class here. So you also want to add, I was supposed to like check tests with this, right? But because of time, I will just define every method we also need that we want to be unique to this subclass also, so that we can just test everything all at once. So now don't forget, since we are adding exclusive members to our lists, we need to have a method that will do that for us, right? So that when the manager picks up our own phone, so she's trying to see that, okay, fine, we have 4 customers, right? Okay, fine, maybe there are requirements, there are criteria to become exclusive customer. Okay, Clement has met this criteria. I want to add Clement to the exclusive list. When she clicks on that ad, what happens in the back end? That is when we now define the method that makes that to happen. So we can now call this method, let's say, add, you can call it anything, right? Let me call it add exclusive. So it also takes what? Self as our normal convention. Then after self, it now takes the new value, which will be the new member we are trying to add. So you can call this one member. Right? So what are we now doing? What do we want this to do? What do we want this to do? So we want it to be able to add new members to our what? Exclusive list. So we now say what? If member not in what? Self dot exclusive. Does it make sense? We are calling back to the self.exclusive lists we've created earlier. So we now want to add new member. So we're now checking if member, this new member we are going to collect, when we are trying to add to this exclusive members, right? So if this new member is not already in self.exclusive, right? So you now say what? So how do we add? So we just say self, don't forget, we are dealing with list here. So you now say self.exclusive. Now this would make sense now if you still remember our list session. I introduced all these lists methods, right? And how to work and manipulate whenever you are dealing with what lists. So in this case, we now say what self.exclusive dot append. You remember append method in our list. Then what are we appending? The new member. Does it make sense? It's making sense, right? Awesome. Thank you. So we're adding the new member. So now we check this new member. Is it already an exclusive member? It is not. Okay. Self.exclusive should not have this new member here, right? So that is fine. Now, so another thing is, okay, we should be able to define or have a program that's when a member doesn't meet the requirement to become or to be an exclusive member, we should be able to remove that member. Doesn't that make sense? Because there must be a criteria you meet before becoming an exclusive member. Now, if you don't meet up anymore, if you fall short, we should be able to remove you. So you just do the same thing and say def remove. Don't forget all these things, you can call it anything, right? So self, this one is important. Then we say member again, right? So after saying member again, so it's still the same thing we are doing here, but we just change the narrative. So in this case, we say if member, who can guess? If we are removing, what are we doing here? When we are adding, we say
Member
if member
in
not in. Thank you. If
member in
member in self dot what? Exclusive, right? Self dot exclusive. So what do we want to happen? We would say what?
you forgot to put folder in that.
You said what? Oh, sorry.
Forgot to put folder.
Yeah. So we say self dot exclusive dot what? Which method are we using? Which list method are we using now? Remove. What are we removing? The member. Does it make sense? So now this would now make me to introduce abstraction in object-oriented programming. Now, if you are inquisitive or curious, the question that will be coming to your mind is, okay, fine, in this program we've been writing, so far, we didn't define anything like lists, but we just come here out of the blue. We just invoke a list method and saying dot remove. We're saying dot append. Like we've been saying print this, but we didn't define prints. So this is abstraction in objects-oriented programming. So abstraction simply means that we just pay attention to details that are what necessary. So we really don't want, to an extent, you to want to know the how. So we want you to have like what, an idea of what is what important, and that is the only thing we want you to focus on. So in this case, just know that when you call remove, it's what remove, remember, as you want. When you want to append, it's what it's what it yields your call. But how it is working, you shouldn't like what be bothered. But does this mean we shouldn't as developers? It isn't really. But to an extent, it's just to what, to ease us of cognitive overload, like having to think every time. How does this work? How does this work? How does that work? I just call print. It's so it just leave all of those things for what? Sometimes just leave them. Don't bother yourself. It's just like you having a car, right? So what interests you the most is what? You just sitting in your car, um, pressing your throttle and what? Gearing to drive, then your car what moves forward. You wouldn't bother what and what connected for the car to what? To accelerate. You change the same gear and what? Change it to what? Reverse. You press the same throttle and the car is what? It's reversing. You don't really care. How would the same turtle that moved forward is still going backward? All that concerns you is what? The car is moving and it's taking you from one place to another. So it's the same thing as abstraction in programming. But this doesn't mean we shouldn't like want to like what go into details sometimes. But many a time they want us to just leave it as it is and focus on what matters. So that is what abstraction. And that's what we just did here with this list method we are calling. Because what we've been calling all along, we defined them ourselves and we could see, but we didn't define append anywhere. We didn't define remove anywhere, but we are able to use them. This is what abstraction in play, right? So now let's go back to what inheritance. So now another thing I want this subclass to be able to do is, okay, fine. Oh, I now want to be able to print out all um all the new lists, right? I should be able to see who my exclusive members are. So I want to define a method that would allow me to see my exclusive members, right? So it's also simple. It's what we've been doing all along. So we just define another method, right? So we say def, and let's call this display. Display what's exclusive, right? So let's say display exclusive, right? So this does not really take an additional parameter because the only thing we are just doing is just to what? To just display what we have. But yeah, don't forget, since it is a list, you can't just print out like that. We need to what? To iterate. Don't forget, we did this in our list class. So you what? You iterate, you loop over your what? Elements in your list. You loop over the elements in your list for you to be able to see the element you have in the list and print it out. So in this case, we now say what? For what are we checking? Member in what? Self dot self dot what?
Exclusive.
Exclusive. So what are we doing? So we want self. So here we say what? We now want to print. So let's say we just want to have some styling output here. We don't just want to print anything. So let's just say we just have something like let's see what we can just have. So let's just have something that would still be appealing to an extent to our printouts. So let's just say we just want to add this, okay, right? So have this and now print what out for us. So after this, Then we now call the iterating variable, the looping variable, which is what? Member, right? Isn't it? This is how to if we can still recall our what? Our
Sorry,
loop.
can we do member dot exclusive?
Sorry,
Like, can you hear me?
I can hear you.
Okay, can we do member dot exclusive?
Is it in for members in member.exclusive? Is that what you mean?
No, like this print that I want to print now. Can we do this iteration that you've done? Can it be member dot exclusive?
No, yeah. What we want to do is, we want to print out um a list, of our exclusive members. And if you check, we didn't really define any method to return exclusive. That is what we are just doing here. But because we are working with an inheritance class, so what we can just do that will make sense or similar to what you just recommended or suggested is doing member dot full name. Does it make sense? You can do member dot. Don't forget, our exclusive member were once a regular members. We were once regular customers, but now they inherit all the properties of the parent class. So now to now get them, so since we didn't define any method to return exclusive, and we are trying to do that in this display or print statement here. So in that case, what we need to do is to do member dot full name. So when we do member dot full name, it will now go and invoke the full name method we define in the parent class. And this is inheritance in place. We have hard coded everything here. So everything we did here in the init method. So it takes everything we need. So you can just be going from one place to another, and you can take instances, you can take methods, you can take attributes, you can take properties from the parent class. So which is what we've done here to print what the full name. So it's still the same thing as printing exclusive, because any user we added as exclusive member here would be added to our list and return their full name. Does it make sense?
Yes.
Awesome. So now let's now test this out. Everything we've been writing. So let's check if it works or otherwise. So the first thing we need to do is, don't forget this. So we don't need all of this anymore. So I'm going to delete all of this. So we can still work with our existing customers. So out of these customers, right? So let's now assume the first customer and the third
Sorry,
customer.
okay, we don't call the customer because
I can't hear you.
it's not called the customer
Your back, there's noise in your background. You have a noisy background. You can drop it in the chat.
You can continue.
Okay. So now we can still work with these customers. So as I have now said, now let's now assume that there are requisites to be checked before you become an exclusive member, right? So now let's now assume customer 1 and customer 3 already they already meet these requirements. They are eligible to become exclusive members. So now don't forget, there will be a manager. It is a manager that is managing them, right? And this exclusive member would be under what? A management. They must be under what? A management. Okay, I say you didn't call customer. Okay, I say you didn't call customer is equal to first choice again. Yeah. So since we want to have like a visualization of what the new child class we just defined is. So in this case, what we just be doing is we would now be, don't forget, this one itself is a class, right? But with the help of inheritance, we don't need to be defining a lot of method and attributes anymore. As you can see here, we use full name. We didn't define any full name here. We just inherit it from the parents. Here also, We didn't like write lines of code in order to meet the syntax requirements. So we just called the super class and used the init to pass everything. And we are able to use all of its attributes and methods, right? So, but in itself is a what? Is a class. So now we now need to create an object class for our manager class. Don't forget our manager class takes four parameters,
Okay,
right?
sorry, before you move on, sorry. Before you
Okay.
move, can you
Yeah,
hear
yeah, yeah,
me?
yeah.
I noticed that member is not defined, like does not like how is the program going to understand that member is customer? I don't know if you understand my question.
Okay, so this one is outside here. This and this, they are different. Where we used member is a method here, but here is attributes. Don't forget, in our class, in our previous session, we said that every class should have the capability of attributes like features and also the capabilities to do something. Now, the capability we want this class to be able to do is after we have a manager, we want that manager to be able to add exclusive members. We want
Yeah,
that manager to be able to remove exclusive member. And we want that manager to be able to check the list of the existing exclusive member. So
yeah,
now this is a separate method. It is this method that will now accept a new value as its member. This would also accept a new value as anything we enter here will be replaced by member. Does it make sense?
sorry, I still don't get.
You still don't get? Okay. Let me take my time to explain. So just visualize what we've been doing all
Yeah,
along
yeah,
in our parent class, right? So we said that a class by default, right, must be able to have attributes and capabilities, which you cited attributes to be noun and capabilities to be what? Verb.
yeah,
It is under attributes that you can define features that are unique to members. In this case, the new class we are defining is concentrated on managers. We want to have a manager objects. We also want our managers to be able to what? Interact with our what? Bank application. So, but this manager should be able to what? To also have their first name, last name. They should also have their balance. In addition to all of this that we've been working with, because essentially we want them to manage exclusive members. You know, exclusive
mhm,
members are being treated differently than
yeah,
how regular users are treated. So it is now here they will now also accept an extra argument where they would store members that are what eligible to become exclusive, right?
yeah,
So that is what their own compulsory attributes. Also, now that we understand what their uniqueness is, so what can they now do, right? It is their responsibility to know who is eligible and to know who is not eligible. So this is where we now define capabilities. Okay, now what they can do is they should be able to add new members that are eligible to become exclusive. Okay, maybe the requirement is you should have a fixed deposit of 1 million annually to become an exclusive member. When they audit, so customer one and customer two meet these requirements. Then after a year, in the subsequent year, customer two fixed deposits was what he unsubscribed from fixed deposits and what takes out and withdrew. He used the withdrew method to take some what amount out of his savings account. So he now changed from fixed to savings. So he withdrew from his what savings account. Now his current balance is now what 500,000. Now, if the requirement is 1 million to become an exclusive member and you are now having 500, what happens? We need to remove you, right? So now we
Yeah.
also need to have a capability in our what subclass that would now that will strengthen us to be able to delete anybody that does not meet our requirements. So in this case, that's why we now define another method here. So it is now in this method, we now say this method, this member you are now seeing here, is this member that will now add. Okay, customer 2 does not meet this requirement again. We now replace member with customer 2. So once we give this value, this method, right, when we invoke it, by the time we create objects, if we invoke it, we now add customer 2 here. If we now check the new list, customer 2 should not be in our list again when we loop and check what we have afterward. Does it make sense now?
Yeah. Yeah.
Awesome. Awesome. So let's have some examples. Let's have some interactive examples so it would make more sense now. So now, currently we have 4 customers. So as I have said before, manager is also a class on its own, but a subclass. So now, in this subclass, we now want to create a manager's objects because a manager should also be able to do all of these things and has its own unique attributes. So the first thing you need to do is just the same thing. So you can call this mngr. You can use that as your um what as your object or instance, right? So we now say what? So what are we calling? Are we calling first choice or manager class here? What are we calling?
Manager class.
We are calling manager. Thank you. So in this case, we are calling what? Manager, because we are creating a manager instance, right? So we now say manager, right? Then the self can be skipped, right? Because self is what will be replaced by this mgr objects we've created. So we now need to give our manager his own unique attributes. So let's say our manager in this case is Ogun Shakin, right? As our manager first name. So don't forget, manager is taking 4 arguments. Then the last name Babatunde, right? So then as a manager, so expectedly your figure should be close to, so let's say 90,000. Then now this is where we now need to include the new field we defined in our subclass. Now we now want to, since customer 1 is eligible to become exclusive member. So we now need to we want to assign customer 2's account management for Ogushakin, who is what our manager. Therefore, Ogushakin is the what manager, account manager for what? For who? Customer 1. So don't forget, it is a what? Is a class, is a list, right? So inside this list, right? Inside this square bracket. So you now put CUST, right? You put what? CUST. So we've been able to, so simply we've instantiated a manager object. So after this init method here would be called as clearly emphasized. So it will be called. So it will replace Ogushakin with first, Abatunde with last, balance with $90,000, and this exclusive, since we are providing an argument, to be replaced with customer 1, right? So that is that. So now let's now see inheritance in play. If you see here, we didn't define anything like email address, anything like first name, self.first name, self.last name. We didn't define them. But let's see if we invoke all the attributes we defined in our superclass. Let's see if it is accessible to our subclass, in this case, our manager object. So let's now see, we want to print our mgr email. Don't forget, we defined email in our superclass. So we want to print our manager email. So let's see if the superclass is accessible or not. What happens? What do we see on the screen? Even being a subclass, we are still able to print this email address we defined in our superclass. So this is inheritance in play. We don't need to be repeating codes. With inheritance, we can just what? Follow the syntax, right? Then you call any attributes, you call any function or method, right? From your parent class, anything you want. If I also do manager dot first, what should I have here? Should
First
print the
name.
first name, Ogushakin. So now let's see if we are still compliant with the balance private attribute. So let's say you want to print our manager's balance. So let's see what we have. Expectedly, we should still have the same error, right? So it's still what observing everything we've defined in our what previous in our super class, that is parent class. So now let's now say we want to check our manager's balance. Yeah. So this should return our what? Oh, sorry. This is a method. We should don't forget parentheses. So this should return our manager's what? So can you see the same thing? You remember this? We defined it in our what? In our parent class, but we can still invoke it. This is a method, though, but we can still invoke it in our what? In our sub class. So this is what inheritance is essentially. Now, in addition to this, now let's check. Okay, now we are done with, we are fine with inheriting or being being able to access super classes, super class instance variables and methods, right? So we are able to do that. We can do all of those interests and the likes that we've done earlier also. So everything would also be accessible. So now we want to check this new the new methods that is now unique to the child's class. Now let's now see if these are working. Can we add new exclusive members, right? So since we already have an object, so we don't need to be instantiating another object or creating a new instance anymore. So what we just want to do is, currently we have customer 1, but we want to add customer 2 also. Customer 2 is also eligible. So do we still need to be invoking this? Nope. So since we have a method to add what? To add exclusive members, and we coded everything here to append any member inside our what list. So what Ogushakin was asking earlier would make sense now. So this is where we now call that add method. So we now say mgr dot add underscore exclusive. This member you were asking before, it's a placeholder. This is where you now add the member you want to add. So in this case, let's say customer 3. Does it make sense?
Yeah, I understand now.
Awesome. So now we say customer 3 now. So now, okay, fine. We've been able to add, right? So expectedly, we should have how many? We have customer 1 and we have customer 2. Now let's see if our display method is working as expected. So let's print the list. So don't forget, it's a for loop. So you want to send the member iterating variable and assignment to run through everything we have in our list, right? And print it out for us. So you can just say print what? mgr dot what?
Add exclusive.
Display, right? So a parenthesis, isn't it? So let's see what we have displayed on the screen. What is this? One moment.
It's printing out the balance.
Okay, so let's comment out this balance first. So I'm going to comment this out, right? So I'll comment this out. Then we have our manager. So we added first one. So we're adding last one. Then we want to call the display exclusive method. So we say for member in exclusive in self.exclusive, you should print for us the new members dots. Then we want to invoke the full name of our member. See, is where the mistake is from. Do you notice anything here? because I am calling a method and I left out parentheses. That was why it printed the storage location where the values are stored. It's not
Oh,
printing out the value. Do you get?
yeah.
So what we just did now is debugging, right? So now let's print it again and see what we have here. So I'm going to run it again and see. So it should give us, can you see? Can you see what we have here? So
Yeah.
now, so who is our customer one? Let's check our customer one. Clement,
Clement.
right? So we added another exclusive member, which is who? Customer 3. So who is customer 3? Grace. Now we have 2. Okay, fine. Grace doesn't meet the requirements anymore, right? So hence the manager, account manager, right, is doing auditing and wants to remove Grace from the list of what exclusive members. Very easy. So once he presses delete or remove, right? The user experience is this. So we will now say mgr dot, what is that method to delete? We say what? Remove exclusive,
Remove.
right? So
Yeah.
we say remove exclusive. Then who are we removing? In this
Customer
case,
3.
cost 3. Awesome. So in this case, cost 3, right? Then now let's now see our new exclusive member list after removing customer 3. So don't forget your parentheses here. After removing customer 3, what happens afterward? So we are going to see that in play now. So I will leave this so that we can have a visualization of before and after user experience. So when we click on this, so
Sorry,
what do
can
we
you hear
notice
me?
here? Yes.
Okay, why did you explain that none after your experience? Change that print. If you can change it, this form, like the print, not this
Can you
method.
type in the chat? Can you type in the chat? Type in the chat. Type in the
Okay,
chat.
okay.
You can continue.
Okay. So essentially, as we can see here, after applying the remove method, the capability that we have in our what subclass, so then we what printed out the new lists of our exclusive members. So we can confirm now that what we have only Clement, which is what expected. Okay, now going forward, okay, so another member also now aged to becoming an exclusive member. So in this case, we say we want to add new member. So let's just say customer 4, right? So we add customer 4, right? So now let's check our new list. So you can just copy and paste this. You paste. Awesome. So now let's see what we have now. Okay, let me just okay, let's leave everything so that we can have a flow of what is happening. So as you can see here, initially we had Clement and Grace. Then we removed Grace and have just Clement. Then we added customer 4, in this case Motolani. Then we have what Clement and who? Motolani. So that is it essentially. So let me check what I say you did. The output is showing none. I guess it is because you used print instead of return when you defined it. Okay, okay, okay. Yeah. So in this case, we can just say, let's do what's let's correct what's Clement pointed. So just say return. Okay. So
Instead
just
of
want to return. Yeah, instead of print. So yeah. So he's concerned about this none, right?
Okay.
So though it's just since it's working though, but just like it's just individual preference, right? Sure you understand. So as
Yeah.
you can see here, so it's no more showing.
Okay, so what if you want to add members? A new member apart from these four members? Do we have
A
to
new
go,
member.
yeah, do we have to go to the first?
Clement, it's misbehaving, See what we're having here. Are you seeing it?
Yes, yes, yes.
So we need to leave it as print. So
Okay.
yeah. Yeah, I'm listening, Ogushakin.
I was asking, what if we have, what if you want to add,
What do you have? What?
what if you want to add new members? Look,
New members.
different from these four
Do you
members.
mean yeah, you just basically do the same thing. So you just come here, like you just come here, right? Can just say just create a new instance
Oh, okay,
of our
just go.
parent class. So you can just say customer 5,
Okay, 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 okay.
right? So say customer 5 should not be equal to. So this is what creating instance or creating object means.
All
So
right.
is equal to, so we call our parent class, right? So our first name, right? I should also be, I should also have accounts with this, right? So,
Yeah. All right, I
okay.
understand.
So is Victor still on this call? Is Victor still on this call? Victor,
It's still in this call.
okay, he's still on this call.
Yeah.
Okay. So, essentially, okay, so we've created a new object, right? So in this case, I have 100,000. It's audio money. Don't say okay. So that's why I was looking for Victor. I know he was going to shout. So so essentially, so this is basically everything surrounding or around objects oriented programming in what Python. So as I said initially, so it isn't as frightened as it is perceived, or it's like there is lot of misconceptions on OOP. So people like fret out, right? So at the year of its what name. So all I say is what, just understand its rationale and understand its logic, right? So before now, I used to think the pillars, so which we are able to also connect while we are what writing or building our software application. To me, before I used to think, fine, I still need to learn what encapsulation is. I still need to learn um, abstraction, to learn inheritance and polymorphism until I took my time to understand its rationale and logic. Then it was then that I now understand that mere defining a class, having the ability to what have both instances, sorry, both data, in this case, fields or attributes and methods together in the same class is what encapsulation means. And also the ability to control some field in our what instances in the case of balance is also what another another what another meaning for encapsulation. And for abstraction, as we have seen, while declaring or defining the subclass, the child class, right? So we could see while using the functions and methods in lists, and we didn't have anything defined. in our what in both super and subclasses, but we could invoke them and use them. So that is what abstraction in play. Then we did the same thing for inheritance. Basically, just what downloading every methods and instances that we earlier defined in our what in our super class, and this makes us what inheritance. So essentially, so this is what object-oriented programming is in particular. So what just makes it unique is it allows us to write maintainable code and neat code. Can you see how our program is very neat? So we are able to define both actions and attributes, everything in the same class. That's why it's called class. So you have everything together. So we don't need to be looking for one file or the other. So everything is defined in the same place. So we just connect the dots, use this to call this, and it's what give us our what required outputs, right? So if there is any question regarding what we've been through in the past 4 hours, if I am correct. Are we up to 4 hours?
Yeah.
Yeah, just 10 minutes to 4 hours. So we covered a lot. So, and I am glad we are able to cover the key concepts. These are the primary concepts when as far as OOP is concerned. There are still more, right? So we couldn't really like check polymorphism because of time, right? But there are still more. But these are the basics that you need day in, day out while writing, like while writing a production program. So if you're writing a production program, as I have said before, you can use procedural, which we are familiar with, which we've been using all this, which we've been using before now. You can use it. But now look, compared to this, you would want to consider this for procedural, right? So if there is any question, please kindly let me know. Okay, so I'm going to stop recording now. So then we'll take questions in the background. So I don't want this recording to be unnecessarily longer than this. So it's long enough. So I'm going to stop now. So we'll take questions in the background.